all, I start by welcoming you all and thank you for joining us. My special thanks to all the speakers who have taken the time out for today and have come over all over the country. And I also welcome our chief guest, Dr. Seshu, for being here. And now I would request Dr. Seshu, Dr. Bala, Professor Rohit Sinha and Professor Pradeep Yamiyavar to come up to the stage and light the ceremonial lamp, and then we will start the sessions. So thank you very much, and now I would request Mr. Sumantra Bahwa to start the day's proceedings. Thank you.
A very good morning. I'm Sumantra Barua, and on behalf of Autocar Professional, I would like to welcome all of you to this first of its kind event in the Northeast. And I would also like to take this opportunity to thank Dr. Seshu for coming all the way from Chennai, for accepting our invitation and for your support. Thank you very much. India is among the fastest growing economies in the world currently. And it is also the world's second largest two-wheeler market. The largest if you exclude the electric two-wheelers of China, and the fourth largest car market. Along with the growing global megatrend of electrification, India has also embarked on making mass-scale electric mobility a reality. Within India, the northeastern region is increasingly gaining focus, not only as an emerging economy, but also because of the immense resources and potential in various sectors. Not a very well-known fact maybe is that Assam, the biggest state of northeastern India and the gateway to the region, is increasingly getting active in the sphere of electric mobility. For starters, the state is a major market for e-rickshaws, with sales of thousands of them every month. The state government has already conducted pilot projects of plying electric buses for intra-city public transportation. Indeed, a fleet of electric buses for intra and intercity transportation is expected to be plying soon. Not only as a market, but Northeast India is also emerging as a hub for serious developmental activities in the sphere of electric mobility. For example, IIT Guwahati, where we are, is growing as a major hub for R&D work in the area of electric motors and charging infrastructure, to name a few. So, reasons enough for us to co-host this conclave in the premises of IIT Guwahati. So, with those words, I would like to welcome you once again, and also would like to play a short video which will give you a glimpse about what Autocar Professional is. One sec. And it's my pleasure to inform you that coming next month, AutoCAD Professional will turn 14. So I would like to thank, once again, all the industry stakeholders for their support towards AutoCAD Professional. Thank you very much, and wishing you a very successful conclave. Thank you. And I would like to invite on stage Professor Sinha to give his welcome address, please.
So very good morning to one and all present here. I, Rohit Sinha, on the behalf of the Institute and the organizers, warmly welcome all the, our experts and the delegate assembled here for the one-day conclave titled Building a Nationwide Ecosystem, Opportunities in Northeast. As you are already aware that our government, India, has already targeted a very ambitious target of basically starting an eco sort of system of hybrid vehicles and EVs in the country. And the targets are very ambitious because it's touted that probably by 2030 we will be having 100% vehicle on the EV itself. But still, we are standing at the outset of another big technological revolution. Many forums in the sort of country are already started discussing about the challenges in the design and adoption of EV technology as well as the support infrastructure. And as you, as a sort of outsider, I'm not an expert in the area of electrical engineering. My expertise lies somewhere else, which is on a lighter side of this processing engineering. But still, I can see India is a very vast, diverse, and is still a developing country. And of course, adopting a nation-wide EV certainly would be going to be much challenging. But we should not be deterred by this particular thing. This is a sort of a country like India can switch to EVs so easily. But still, if you just recall, we all have witnessed many techno-management feat which has been successfully pulled in our country. Like we have a very high penetration of mobile phones, which was unthinkable 20 years back. We have e-services, e-commerce, banking being spread throughout the nooks and corners of the country. So I hope that with this, we should be able to surprise our skeptics by successfully sort of adopting the nationwide EVs in coming decade or so. This is my hope. In regard to manufacturing, deployment, and the research on EV, I see as an outsider, the Northeast region offers some distinct advantage vis-a-vis other locations in the country. In my assessment, these are the points. Maybe the expert may not be agree with me. That's very right. But what I see that most of the Northeast states are self-sufficient in power generation, or they have huge potential if they can be exploited. And Guwahati has already been identified as one of the few cities in India for setting off the EV sort of, that's what's called electric charging infrastructure in the country. And if we set up the EV manufacturing in the Northeast, certainly it's going to help a region which is not very much industrialized. Apart from that, its closeness to Southeast Asia is going to give them some advantage of exporting it through land routes, and this also falls in the line with our East policy of our Honorable Prime Minister. So if we are basically going to open borders, East borders, probably we have 7, 8 countries around us, and we should be able to explore through land route all these vehicles if we build it in the Northeast. Of course, it can be expanded to any part of India. The Northeast has a very diverse terrain, climatic challenges, and as well as the sparse population, and these are all very good sort of test bed for studying the initial studies about the EV vehicle and their adoption, etc. Northeast has a high concentration of technical institutes of national importance, which can be geared to take care of the human resource creation, training, and the research in the EV technologies, including IIT Guwahati. And last but not the least, the people of Northeast have very high passion for the automobile and newer technologies. In my assessment, I stayed in this region for last decade plus, and I can see, and this can be capitalized for an earlier adoption of EV in Northeast compared to rest of India. This is my assessment about it, and I think that this region offers some sort of advantages compared to rest of India. At IIT Guwahati, particularly in Department of Electronics Engineering, we run a small laboratory that we have titled Electric Mobility Laboratory under the leadership of Professor Praveen Kumar. And his group and his students are actively engaged in the collaborative research work in the EV-related topics. And the idea about this conclave was actually originated in that group itself some time back. And I sincerely thank Auto Professional magazine, and this is a leading automobile magazine of India, for coming forward and actually helping us organize this event so successfully. We are very fortunate that a senior executive of some of the leading EV manufacturers in the country and the research laboratories have agreed to deliver the lecture in this conclave. And we sincerely thank all invited speakers for accepting our invitation and sparing their busy time out of their busy schedule and coming for this conclave. I hope that this conclave would enable the stakeholders in Northeast region, in particularly, to identify the opportunities in this EV revolution, oncoming EV revolution, and also explore the future collaboration with the EV industry. Ladies and gentlemen, it's my great pleasure to share with you that IIT Guwahati, being set up in September 1994, is celebrating in year 2018-19 as a Silver Jubilee year. And as a head of the EEE department, I feel privileged and honored to dedicate this conclave as one of the events to be organized by department to mark the Silver Jubilee year. So with this, I close my address and wish you all a great day ahead. Thank you very much.
And as a co-host, I would be failing in my duty if I don't thank the partners who have made it possible for us to organize this event in the form of sponsors, namely Ashok Leland, FEV, and ANSYS. So I would like to put on record our sincere thanks for the support. And now we begin the first talk of the day. And it's my honor and privilege to introduce the speaker, Dr. Seshu Bhagwatullah. Dr. Seshu, a doctorate degree holder in high-frequency technology from University of Stuttgart, is currently the Chief Technology Officer at Ashok Leland, and he leads the technology functions across all the Ashok Leland Group companies. Dr. Seshu has over 25 years of experience in R&D, technology strategy, sourcing, and telematics with Daimler Chrysler AG. He was responsible for setting up Daimler Chrysler's research center, which is currently known as the Mercedes-Benz Research and Development India in Bangalore, which also happens to be the largest R&D center of the company outside of Germany. Before leaving Daimler, he was a senior director, engineering processes, and product development for Daimler Trucks. He has several patents, including 3 in transportation telematics. He also has about 35 technical publications to his credit. After Daimler, he went to work for Great Wall Motors in China, where he was responsible for research and development. Now it's my honor to invite on stage Dr. Seshu Bhagwatullah. And also, I would like to request everyone to put their phones on silent mode.
So, good morning from my side as well. What does actually one do when the presentation is made by someone else and you're supposed to present it? And you got just 2 hours time in the flight to go through. But then, at the same time, if you see that there is some kind of a discrepancy between the slide and myself, I'm responsible for the discrepancy, not my assistant who put the presentation. But I can tell you, at the same time, let me make it as lively as possible so that we go through the complex topic of building a nationwide electric vehicle ecosystem. You see, it's all about ecosystem, right? The modern technologies that are there today or that will be there in the next years will not happen with one company or one particular thing doing something. It's all about ecosystem. Some of these ecosystems actually span across the continent. Probably they will have to become more multinational than what people think today. And I think when we look at the topic that we need to develop something in this particular part of the country, we're looking at probably parts of the value chain, probably not the overall value chain. Let's look at what this part could be. Now, just 1 second. Yeah. Now, let me first paint what we see as a commercial vehicle manufacturer. The whole CV industry and the product priorities we see in India, first thing is TCO. This country is a very price-sensitive country. There are countries where you would buy a vehicle for a particular special characteristics, like let's say suspension, or you say it's got a beautiful look, or something else. But here in India, the look, the aesthetics comes in the 6th place, seen from an OEM. The first thing is the so-called total cost of ownership. The second one is the budget that's available to you. Now, third one is the aftermarket reliability. The fourth one is the safety. Imagine there are countries where safety comes right in the first place. Now, 4th place is called safety here. Now, the next one is the comfort. You know how our drivers sit on the trucks and the buses, even until recently with the passenger cars. Now, it will change as well, but today, seen from us, it's a total cost of ownership. The most important thing. And then the budget that you have to buy or to lease our vehicle. So, and on the other side, the market conditions, the harsh road conditions we have in this country. And then the market is dominated by informal spares, not the original spares. And you have a very high manufacturing complexity. You can imagine, you will have to imagine I came today from Chennai. If I had one factory in the country, I would build everything in Chennai. I would have to transport all the way to Assam. Now, it's a logistics nightmare. It's a supply chain that is very complex compared to most of the other countries we know which have established automotive markets. This is a very, very different country. So seen from an electric vehicle point of view, they will all become a parameter someday. Now, the economic factors, look at them, for example. Now, CO2 emissions, energy consumption reduction. Now, you look at reducing the dependence on the oil import, or some of the parameters the national government is looking at. Using electric vehicles, they would like to compensate these two parameters. Now, there are incentives being given. FAME is one of them. The tax benefits are being looked at. We also have the new mobility paradigm. People are talking in the national government about multimodal transportation. For some of you who probably may not have heard this word, multimodal transportation is all about, for example, you leave at home and you have to get to a particular place which is not nearby. You first require maybe a taxi, even a two-wheeler maybe from your home to some place, and which will take you to the airport, and then you take the flight. Or you go to the railway station and take the train. Now, all this that you use in between could be a two-wheeler, a four-wheeler, maybe a bus, maybe something else. That's intermodal transportation. Imagine this intermodal transportation to become completely electric. That's a challenge as well. Now, recent trends are, that there are this 10K electric cars, the FAME 1 bus tenders, 400 plus tenders that are coming in. So there are lots of things that are happening in India right now. And the key takeaways for us as a car maker is the demand on electric vehicles is going to increase in the next 3 to 5 years. Putting some numbers on what will be the case, what will be the scenario in next 3 to 5 years is going to be difficult, but we will attempt to do so in the next minutes. The next one is the possible migration of high mileage in ICE or the intermediate commercial vehicles. These are typically, 10 tons, 15 tons, is a category people talk about. These, we believe, will slowly move to electric vehicles. And the last one is the viability of electric vehicles in the personal transport, which will be the last one, the passenger car vehicles. For us at Ashok Leyland, we have a big strategy that's more or less being ratified by the board of Ashok Leyland. That's about, we have already more or less shown to the market the so-called Circuit series, which has a fast Circuit F, fast charge, then we've got swap, then we've got a high, ultra-high charging. These are 9 meters to 12 meter buses. Then we also, because we also, today we make engines, the so-called auto diesel engines. We make these engines into power solutions, like use them for generators and so on. So we would also like to use this electrification getting into the power solutions business as well. Why I want to bring this topic is because there is potential in this part of the country as well for this particular business. Now, ELMCV, it's about the electric last mile connecting vehicle. The last mile and the first mile are supposed to be the ones that will actually take a country to the next level. If you can master them, in the middle, you've got these big transportation systems like trains and whatever, all these big trucks that travel, thousands of kilometers, they carry 50 tons of luggage. That's not an issue. The issue will be the first and last mile. So there will be quite a bit of attention given to the last mile. The first mile will take a little longer, but the last mile will be the one that will probably come. So we already look at the last mile as one of the priorities for Ashok Leyland. The last one that we already are more or less conceptualizing is the so-called modular electric bus. It's a bus that has fixed front and the back portions, all set, so to say, in a modular platform, and the middle one is something that you can extend where you have more batteries or whatever that comes in between. So this is going to be a modular platform that will suffice lots of duty cycles. When I say duty cycle, I mean the application cycles. So we're also looking at, right now, partnerships in the batteries, motors. We have Dr. Bala sitting here. He will be the architect for quite many technologies in the motors that we will develop and market and put into our products in the next years that will come from NFTDC in Hyderabad. So he's sitting here. He's the man who actually is driving us quite a bit. In fact, that's putting it too politely. He does it a little bit more. We also look at power electronics. We're looking at partnerships in power electronics. We also look at range extenders. Range extension is all about, people typically talk about the city buses becoming electric and whatever, and maybe 100 kilometers you can make electric. But what do you do if you're looking at 300 kilometers and beyond? Now, the battery, 300 kilometers and beyond at 40-ton luggage weight. Now, where? You have no chance. So you require very different technologies to do such a thing. So we look at, on the paper right now, we look at fuel cells. A combination of fuel cell powering an NMC battery, that's a nickel manganese cobalt battery. And fuel cells are ideal as a constant power source at a constant torque. And they then power this lithium-ion battery that gives a torque up and down. So we're looking at it right now. So we're looking at all kinds of partnerships right now. The objective, naturally, is to optimize the cost because I can't buy them from Germany or United States or somewhere else. They all have to be made here. The localization is the key for electric vehicles in India to take off. So the next one is, ultimately, it will have to get to something called what we believe internally is the EMAS. EMAS is e-mobility as a service. We have actually won 2 contracts right now, one in Tirupati, one in Ahmedabad, and in both the cases, EMAS is already a business model. Ahmedabad said they don't have the money. Tirupati said they have the money, but they don't want to spend the money on this. So we said, we will give you everything. You give me the route. So we said, the bus belongs to me, the driver belongs to me, and everything belongs to me. You just pay per kilometer, or whatever unit we agree on. So I maintain the life cycle for this bus, and you just pay every day something. Now imagine I am actually making right now losses, because this is a volume business. Unless I have certain amount of volume that I have, that I have to get, the business model doesn't work. But how do you seed the market? How do you develop a market? This is the only one. So I think in India, probably this e-mass will become right from the first day the model to be used, because it's a very cost-sensitive country. So Ashok Leyland, the upcoming programs, it's not a sales pitch here. It has some relevance to what we're talking about. What you see here probably will be adapted or being adapted or already adapted by other OEMs as well. Now, for example, a goods carrier, ELCV. It is, we have a small little platform that goes up to, about 3-4 ton, and we would like this to be electrified for the last mile. And the second one you see is the passenger carrier. We call it a ho-ho, a hop in, hop out. We believe that there will be small little these cars running in smart cities in future. They stop at every 100, 150 meters, and people jump in and jump out, hop in, hop out. They're all going to be electric. So, and we're betting on this as well, that this will be an interesting thing for people for short distances inside the city environment, downtown environments. Now, the next one is a modular electric bus program, as I said. This will be adapted. It can be anywhere between 6 meters all the way to 12 meters, where the middle portion changes based on the application. The ePSP is about the power solutions business. We believe initially you may have hybrid technologies coming in. Over the time, they could as well become completely electric. Defense applications, Ashok Leyland has a big defense division. About 90,000 soldiers every hour are transported by the Ashok Leyland vehicles, and most of these higher carriers like bridge carriers and weapons and so on, the intercontinental ballistic missiles, they're all transported through Ashok Leyland vehicles that go from 4x4 all the way now to 12x12 configurations. On the EV market scenario and the policy progression, you have seen that right now the market is in a nascent stage, but you see the potential coming in. It could grow after the Euro 6 or the BS6 emission norms get settled on, which is going to start on the 1st of April 2020. And once that happens, the attention will be diverted to the electric vehicles. Right now, the country is busy with the Euro 6, which itself, there will be big things happening as well. Once you have the Euro 6, you still don't see roads becoming better or the emission becoming better. You still have 10 million trucks and buses still with those that are more than maybe even 20 or 30 years old. Now, they all have to come to Euro 6. So we're actually lobbying to the government to do some kind of a scrappage policy to replace the older ones with the newer ones. That has to happen as well until you see some change in the air that you breathe in on the roads before electrification really starts making a difference. Now on the challenging part, which is interesting part for all of us, because these challenges become goals for this region. India currently has no local EV battery manufacturers and no raw material base. You can't develop raw materials just like that, right? So unless there's some kind of a new material being used someday that India has in abundance, that's where probably things could change, but that's not going to be the case for quite some time. Now, EV battery manufacturing has to take place in this country. Otherwise, this will never take off. That's number one. Number two is the low supplier competencies for EV-related parts in India, and thus rely majorly on imports. Now, as I said, our partner from NFTDC, Dr. Bala, is one of the pioneers, and we hope to get this localization done as quick as possible, at least for motors, which forms the second most complex or costliest thing in the commercial vehicle business. Lack of clear policies is another challenge for supply manufacturing and for recycling. Recycling is a big thing, right? For some of you who someday probably should become entrepreneurs, this will be an interesting thing for you. A battery can be used maybe up to 85% of its power charging state of charge, and after which you still have 80%, 85% left out, and corresponding so much of life. But you have to do something about it because it can't be used for the bus or the vehicle. So what we call the second life. The people talk of third life as well. And after the third life, you recycle it completely. By the time we get to a complete proliferation of electric vehicles, we believe all the raw materials in some form or the other can be gained back through the recycling process and bring them back into the chain again. So there needs to be policies about it. Now, the electricity mix is still, is dominated by fossil fuels in India. So that needs to be looked at as well, because the ultimate product is electric, but how you make all the components and the factors are still emitting CO2 and whatever. So it doesn't help. So you have to look at, the wheel, the well to wheel, and whatever people talk about. The whole thing has to be sustainable, gained through the sustainable means. Now, infrastructure for charging stations in cities and outside of cities, they're all challenges right now. Now, there are lots of players, and there will be many players, as this country is big enough for many, many players to come. Maybe in about 10 years, you will see maybe 20 players coming in, offering technologies and products here. So a few first tenders that we see coming in India, they're very, very nascent. Add them all up, you're looking at maybe 600, 700 buses tenders coming right now. It's not a big market compared to China, our neighbor. It's the world's biggest market, and we are nowhere near that, what we see in China. Then the small information for you is, if you look at the blue curve, which is a Gartner's hype curve, which everyone knows, it's like the hype is just right now coming into India. That's what you see, the bump on the blue curve, this one. But as time passes by, the reality sets in, and this will go through the typical Gartner phases, and at some point or the other, it settles down. Now, what is interesting for you is the yellow curve, which is the battery cost. So there is an inflection point. The inflection point typically is around 2025, where the kilowatt hour per dollar price, if it comes anywhere near 150, maybe even $200, let's say, that's where people believe the inflection point happens, and that's where you can compare the costs of electric vehicles to what we have today with the normal auto diesel engines. And that could happen by 2025 or maybe a little later in India. But if that happens, I think electrification will take off very, very fast. Now, the technology options that people look at, so that you know what consists of such an electric vehicle, is that you've got all kinds of batteries. In India, we look at, for Ashok Leyland, we look at the so-called NMC batteries, but we also look at LTO, which is meant for very fast charging. We also have these three options, what we call the fast, flash, and the swap. Now, let me take 1 minute to tell you what this really means. You take a city bus. City bus goes to about 35 kilometers or 40 kilometers, and it comes back to the depot. Now, you take the battery out, put a new battery in that's already charged. Now, what does it mean? It allows you to go with a small battery. It brings the price down. That's one of them. And so, but it's limited in the sense of that you always have to come back to a place where the batteries are charged all the time, and you have to do this within 2-3 minutes, and this mechanical putting in, putting out may have some effect on the life. We're observing, we right now have a fast swap. We're running lots of buses, collecting a lot of data, and we still do not see any big failure modes, but we will see. We must have changed them more than 70,000 times already. So the flash is all about that, in India you have this specific word called Mofussil, which is intertown buses, maybe 100, 125 kilometers, and either you could swap will be difficult for 150. That means the battery becomes so big. So batteries that you charge there within 10, 15 minutes. So, and for that you typically could make use of this ultra-fast charging technology, lithium titanate oxide, LTO. But it's a bulky thing, and it's not as efficient as other batteries. So you can read all of them. There are disadvantages, the advantages of each of the technologies. But so we in Ashok Leyland are looking at all the three options. Now, we're also looking at all the motors. I think I would leave this motor part because you will hear from Professor Praveen and Dr. Bala. They're all motor experts. They tell us, Seshu, you have to look at permanent magnet, switch reluctance motor, whatever, all of them. Now, the topology, that's another project that we have with IIT Guwahati. This is all about, what kind of combinations you have in an electric vehicle architecture in the powertrain. For example, based on a particular application, you choose this particular battery, you choose this particular motor with all kinds of other options that are possible in an electric vehicle architecture. This is a big, long project with Professor Praveen. We are we're just making some beginning steps in this project. And the last one is the range extender. As I said, the SOFC, solid oxide fuel cells. That's right now on the paper, but we will get to the real designs in the next 1 year. So how does actually such a powertrain layout look like? The one you see on the left on the top, you see typically one of our chassis-based common electric architecture that we use right now. Not going into the details, what typically is interesting for you is all these have to come from this country, from India. If I import one of them from outside, my cost explodes beyond the so-called affordable TCO that makes a product interesting for the buyers. Now, there are also lots of trends you see. For example, the e-axles with suspension. So it's like who owns the value chain? Let me take 1 minute to explain. Now, there are people who believe that axles have so much of space that you can have motors in the axles, even battery in the axles, and all you need in future is 2 axles and put a box on the top of it with a controller, and that's a bus ready. Now, so axle people want to own the value chain. There are others who believe that I actually have my e-drive, and I actually put everything in the e-drive, and all I need is just a dummy axle, and I have all the e-drive with all the complexities, and I want to be the owner of the value chain. There are others, the battery guys say 60% of the bus is battery. Now, I want to actually be the owner of the value chain. So there's a big fight happening on who owns the value chain. So this is for the people who want to read, and the future electric vehicle designers here, read in the internet on who owns the value chain for electric vehicles. It's going to be an absolutely interesting study for you. Motors. Permanent magnet motors are the ones that are loved by the OEMs today. There could be others over the time. Major roadblocks are cost and availability of the rare earth elements for magnets is a big issue for us today. Control systems for PM motors are more complex than other ones. So we believe that Indian OEMs should look for producing the motors either in-house or develop local supplier base. That's for northeast of India could probably become potentially a place for such a thing as well. Battery packs, as I said, you see the blue dots actually tell you what was expected, what was projected, and yellow ones are now, so to say, what is happening and what will happen in future. So this is the point, as you see here, this blue line, that's where you would see by 2025, you will probably see the battery prices, kilowatt hour price coming down to about $150. And so the challenges here, naturally, battery business is a volume business. Today, until 2025, how will you manage? If I have 100,000 buses today, I would already make the batteries at $200 or even $150. But the market volumes are not there. So I will have to wait either develop the market so much using the government policies, or the battery prices come down. That's an equation that needs to happen at some point. As of now, we have another challenge, is the availability of competencies in India is going to be a big issue. And I know the educational institutions are working on it, but today it's very difficult to get people. And unless you have the people, you can't develop the industry. So charging technology, this game changer. There's another big philosophy change difference in the world. There are countries, for example, look at in Western Europe. You look at Netherlands, look at Germany, look at others nearby. They believe that there has to be a combination of infrastructure and the technology, the vehicles. So I can imagine countries like Holland would actually go for so much of infrastructure. Every 3 kilometers, you have a charging station. Now imagine if you have every 3 kilometers a charging station, all I need is it's a small battery. Just $100, $200 maybe, small battery. So every 3 kilometers I can charge, just for example. Or countries that are big, like India, China probably, or United States, you cannot put chargers all over the place. But at the same time, cities are the places where you want the emissions to be reduced. So that's where you would have to decide on infrastructure. So India, at some point or the other, has to take, there was a beautiful announcement recently I'll talk about in 1 minute. So what is actually happening right now is you've got a vehicle, you've got a battery, and a slow charger. They're all available globally. India as well is going for it. This means it's a simple, staff and campus applications are possible, not competitive. It can't be used for everything else. You look at vehicle plus battery plus a fast charger. It is possible globally and also in India. Expensive and limited city applications are possible. If you look at the vehicle and the battery swap, mainly in China today, and in India starting, we're the first ones to do that, competitive with energy contracts. It's possible. Now you look at vehicle, battery, and the flash charger, it's available outside. In India, not yet. Infrastructural constraints and risks because you require a lot of electricity at a particular point to charge. So you've got all the other combinations of the matrix. This is fuel cells at some point will take off in India as well, I'm sure. So you look at the range versus battery capacity versus infrastructure. Now, this is, for example, as I was telling verbally, if you have a lot of charging infrastructure, the battery capacity could be low, and range is going to be low, but the vehicle cost will go down. That's a nice part. If you take, for example, infrastructure being less, that means every 100 kilometers, every 80 kilometers, battery capacity has to be high, and the range will be higher, though, but the cost goes up. So it's a compromise between these things you have to look at. So, but for India, you see how is the power generated and made available everywhere will be a big question for us. Now, on the left side, you see the Ministry of Power recently said everybody is free to set up EV charging stations in the country for personal and commercial use without the need of any license. This is, I think, a game changer. Imagine from the airport to here, every pan ki dukan can put a small charger. And you know, Badr, the problem is you can put chargers, but how many cars can you park there? You know, imagine like you go to the petrol station today and then just 2 minutes later the car goes off. But when you have to charge this vehicle, they're required to stand for a long time. How many can you accommodate? So the best is naturally every pan ki dukan, so to say, will have one charging station. So, and this is a personal business model. India, I think, has a wonderful idea here. I think this will take off, should take off as well. See, yeah, oh yeah, yeah. I can. I can imagine. Well, there are other things we have to take care, but this, I think, on the policy side, a nice thing. Yeah. So, EMAS, e-mobility as a service. Now, can someone tell me when my time is running out? Because can anyone keeping watch? Time on? 5 more minutes? 10 more minutes. Thank you. EMAS. E-mobility as a service. As I said, EMAS has the advantage that you will be able to reduce the cost for the customer. Because how can one buy something? Initially, we will have to take the cost on our side. Today, we won 2 contracts, and they're so expensive. The return on the investment is so far in future that we had to go to the board and tell them that for the next 10 years on this particular project, you get no money. And they're not very satisfied, you can imagine, because they won't make money, right? The board of directors want to make money, and they want you to make money. And they want to create employment, they want to take care of hundreds of thousands of people. And you come and tell them you take the money and then nothing comes back. So this is not easy stuff, but we managed to convince them to collect some vital data. So we chose actually Ahmedabad for arid, semi-arid region being hot, and in Tirupati it's a hilly station and hill station, so you have these extreme 2 cases to collect a lot of data. So, but the advantage naturally is the aftermarket support and operations. They can be done through local dealers. You have to go in for partnerships. Turnkey, bespoke e-mobility solutions. We can literally offer whatever people want. Energy management solutions can also be done. So all the responsibility lies with us as an OEM or whatever company that we represent in future. That means OEMs will become more or less operators of bus fleets. So we will become a fleet provider companies at some point in future. This is a major change. It's going to be interesting. For example, you look at the control center and protocols to be in line with RTA requirements and specifications. You know, we already have a framework which we use naturally to change the business model according to the customers. So now, power solutions business, just want to put a slide here. We are also thinking of supplying our hybrid power supply solutions to these categories of applications. Then last slide from my side is my summary and the suggestions. Northeast region should have local policies that will help the ecosystem develop. The state governments actually should probably be more proactive than the center. The center is busy with other things, and you can't wait for the center to do certain things. I think it should be possible for local governments, with your help, to lobby there. Startup world should be supported with sufficient finances. You see, why do I put this startup world is that we observe worldwide what is happening in the startup world in the new technologies. Now, the best battery technologies, the best battery pack technologies don't come from these big companies like LG Chems and others. They're great companies, but with all the respect, but the really energy density, power density comes from smaller companies. They do thermal management much better, and the packing more cells in a small volume. There's so much of innovation happening there. Now, you know, in the battery business, it's all about thermal management, most probably, right? So there must be a way to let startup companies come in this region. That's a main topic today, right? For the whole day. Educational institutions should act as partners to bring all the ecosystem players together, which is happening to a certain extent. It should become more and more, not just in the IITG, but all the others should also actually get into that business as well. Now, industry to invest in R&D in these fields I'm talking about myself and people like us, the companies like ours. Industries and educational institutes should approach world technology leaders to localize them in India. Initially, probably the technologies, for certain things, they have to come from outside. Right now, the gap is still very, very high. You know, we thought in electric vehicles the world is flat, but unfortunately it is not flat anymore. There's already, the curve came in. People who are making leaps in technology, and India is still lagging behind. So something needs to happen there as well. Sustainable means to generate the power. As I said, we still are a very fossil-based country, but we have the area. It's a big country, so there must be some way of generating power through sustainable means. When I talk of sustainable, I mean, you know, environmentally friendly as well. Charging infrastructure, is it a small-scale industry as well? There is, it looks like. Subsidies in the ecosystem, it's not just in particular in the batteries, but the whole ecosystem has to be subsidized as well. The last 3 points are electrified multimodal transport. If you just concentrate on city buses and the rest gets neglected, it doesn't work. So you will have to have policies like 2-wheelers and 3-wheelers, 4-wheelers, everything has to become electrified. And the new business models, renting, leasing, pay-per-mile, etc., they all have to become over the time. Renting probably will not happen. Renting could happen in two-wheelers, maybe in cars, but I think pay-per-mile will become the mode of business model for big electric vehicles. I'm talking buses and others. Educational institutions to create competencies in all aggregates. As I said, today we could employ dozens of people. We don't get them today. So I think that brings me to my last slide. Thank you for all the attention. Thank you very much.
Dr. Seshu, thank you very much for a very insightful presentation, and really it gave us a very comprehensive overview of where things are and the road ahead, and also thank you very much for your concluding remarks. Now the floor is open for any questions to Dr. Seshu. If there is any, please raise your hand so that we can, one sec. Please introduce yourself and your question.
Good morning, sir. Thank you for your nice presentation and enlightened us with your very thoughtful knowledge. Actually, I'm Dr. Poriksit Gogoi, working in a college in Nagaon. So actually, I concerned about the batteries. So it's all about the production of batteries and all. So is there any very good technology in India to produce electricity using batteries by using biofuels and all? Because I'm working in biofuel production and this biofuel, fuel cell in United States in last 1 year back in Georgia Tech. So they are thinking that if you produce electricity from biofuel, that biomass, lignocellulosic biomass, that will be a very good technology. Is there any program is going on in your company so that you can do something?
See, we are a commercial vehicle company, right? We don't actually make batteries, we don't make any energy, but we would love to partner. You see, when we went to Ahmedabad, we asked Ahmedabad that the energy that they give us, is it sustainable? Is it coming from, let's say, environmentally friendly means? They said no, right? Although, by the way, it's just because, Ahmedabad still is much better than most other places because they've got a lot of solar energy coming up, but it's not yet so much that so you're right, by the way, that will have to happen. There's no other way. So if the problem today again is you produce in some place for example, we told them we've got a solar farm, a wind farm in the southern part of India, and we're producing excess, but we don't have any energy production in another particular state. Can we compensate across the states? I feed my energy that I develop using sustainable means in, let's say, Andhra Pradesh, and I collect that in Gujarat, which is not yet possible today. But anyway, the other point. So you're right. Please, this is welcome. Absolutely. Yeah. Maybe you should look at using biofuels for fuel cells as well someday.
Yeah. Thank you. Thank you.
We have one more question. Kindly introduce yourself before asking the question.
Myself, Dr. Arun from MNIT Jaipur. I have one question. What exactly the Ashok Leyland is facing as a challenges in order to develop a world-class infrastructure like charging system or maybe the quality of the overall system? What are the main challenges you are facing on R&D side?
As a commercial vehicle company, we actually do not really do too much of research. Research is done by educational institutions, research institutions, or labs that are governmental labs. We only do advanced engineering. That means if you have a product that is not yet available, but is more or less working on a table, that the principle has been shown, we would sit with those companies and industrialize it, because we're good in industrializing, right? That's what our core competency is. We integrate aggregates developed by everyone else. So, and these aggregates are not there. In the electric vehicle, you saw the powertrain. We neither have the battery, we don't yet have the motors, we don't have any of them. That's a challenge today, not just only for Ashok Leyland, for everyone, right? So today, our batteries that we have today, they come from somewhere else, outside of the country. And that's the reason, although 60% of the bus today is battery, but today, because I'm importing, they're 75%. If it an engine, auto, diesel, whatever, auto motors as they call, is just about 15%, 20% maximum of the bus today is the engine. The battery has to come down to that, battery plus a motor. So that's a challenge.
Sir, myself, myself Pankaj Sharma from Zorat Engineering College. So, sir, if we see electric vehicles which are there in the metros, like in Delhi, we have lot of electric e-rickshaws. But if you compare their fare with the normal, rickshaw, like for a distance of 2 kilometers, if the normal one is shared auto is charging 5 rupee, then e-rickshaw is charging 10 rupee. That is one of the major obstacle in India, if you see, because the people will go with the lower cost. So, how you seems to tackle this situation?
We were talking about it, but let me answer one more time. He is right, because he bought this. He bought the battery, he bought the vehicle at a higher price. That's the reason he charges higher. So the question lies in how do you make this cheaper for him? That's where the solution lies, right? So how do you do it? You, for example, the rickshaw maker should actually have leased him at a cheaper price, where the rickshaw owner or rickshaw maker should have taken the costs on him, and he would get the return on the investment at a later date. That's not happening today.
So that is also happening near the Dwarka Sector 9 metro station, if you see. But here the obstacle, then the auto drivers, the e-rickshaw drivers who are leasing, they have to pay around 350 to 400 rupees per day. So from that point also they are being demotivated, because they say that 350 to 400 rupees daily they have to pay. So is that a fair price, or the big markets are making money from that?
Unfortunately, there's no one making money here today. The price is justified. It's because there's no model available. In fact, it's like a business class ticket or a normal ticket, right? So if for example the flights would consist only of business classes tickets for whatever reason, it would be cheap. It would be costlier, right? But anyway, so the example probably is not appropriate. But today the price of this vehicle is 3 times more than the normal e-rickshaw. That's it. You will have to make it cheaper for him somehow.
All right, we have time for one last question here, and kindly introduce yourself.
So hello sir, I'm Ankit from ANSYS. My question to you, just to second his comment, is like, why policy making in India for EV is not so impressive like what we have it in China? Because in last few years we have seen the sale of EVs in China has accelerated. But if we try to implement the similar policy, that would help India also. But do you see any reason we are not at that stage?
The reason for that is, not that I know everything, but it looks as though that the government is probably very busy with many things. India is not an easy country, right? But China is equally not easy, by the way. I know that as well. I worked there for some time. But it looks like, India is a country where, being a democratic country, you can only do certain things. Now imagine if I do scrappage scheme, like any truck that's more than 15 years old should be scrapped. Now imagine, 85% of the trucks are owned by individuals. That's the only means of income for this poor man. And he drives a truck for 20 years or 30 years, and he's got no money for a new truck. Now, what would you do with this guy? Now, you would like to have him using an electric vehicle or a Euro 6 or BS6 vehicle. So So you would actually first do something to them before you come to this expensive stuff, what we're talking about. That's one of them. But at the same time, you're right, by the way. Policy and on the national level, I think will have to happen much faster than what is happening today. You're right, yes. I don't have any serious reason why they shouldn't be doing it. I don't know.
Yeah, because I got an impression like by 2030, all vehicles should be EV, and then they came back and said, okay, no, like, let's keep it to 40, 50, not more than that. Yeah, if they are very aggressive, I think so they can implement it, but
Yeah.
yeah.
You see, I mean, if government today says all passenger cars should be electric, the sales will go down to zero because no one can afford a passenger car. There are more than, how many millions? 19 million people working in automotive industry in this country. They would all be jobless. Would you do such a thing? I don't think. Now, battery prices are very expensive today. So policy should also consider what is possible in the country. Maybe there is something there. There must be something there. I can't imagine all those big brains sitting in the national government. They must be looking at all the compromises. So it has to be a soft introduction. And ideal would be naturally to make the city buses, which is under government-owned stuff, they could take a decision there and create a volume. If they create a volume in the city buses level, then the battery prices will come down and others will adapt. Price comes down, then I think it's a chain reaction that will happen.
Thank you, Dr. Seshu. There are more questions, but due to paucity of time, we have to stop here, but I'm sure they can be asked offline. But Dr. Seshu, I would request you to please stay on stage, and I would request Professor Yami Avar, Head of Design Department at IIT Guwahati, to felicitate Dr. Seshu Bhagavatullah. With a gamusa, which is our Assamese traditional towel. Bouquet, and a book which Dr. Seshu, we hope you will like it. Thank you so much. With that, we come to the first break of the day. That's a tea and coffee break of about 10 minutes or so. So I would request everyone to please assemble back in the hall in about within 15 minutes, please. And not later than that, a humble request. Thank you so much.
और एक माइक है क्या? नहीं सर, एक ही माइक है सर, इसके कॉलर माइक है।
कॉलर माइक में
आप ले लीजिए कॉलर माइक।
ये गेस्ट को दे सकता हूँ।
हाँ, दे सकते हैं। ठीक है तो सर, ठीक है, बाद लगा लेंगे।
हाँ
हाँ, वो उसको बुला के लेके आओ, मैंने बोल दिया उससे। यहाँ बैठा है, यहाँ से पीछे बैठा है। ऑलरेडी हाँ, ये है, फोटो है प्रेजेंटेशन में
सबका है।
हाँ,
क्योंकि वो क्या फोटो में मैंने निकाला मोबाइल से बहुत ब्लर आ रहा है
वो सही नहीं आ रहा है।
और वो प्लस वही है।
इसको बंद करो।
माउस है तो भैया बैग में।
हैं? ये काम ही नहीं कर रहा है ये।
कीबोर्ड यूज़ कीजिए।
वो कहाँ है प्रेजेंटेशन?
यहाँ पे,
हाँ, इसको रखो, इसको निकाल दो।
हमने क्या किया है आपने? टचपैड इज नॉट वर्किंग विद। या प्लीज। हाँ,
इसको निकाल दो।
प्रेजेंटेशन से on this. What happened to touchpad? Huh? Touchpad is not working in this laptop.
He is Dr. K. Bala Subramanian. A quick introduction. Dr. Bala, as he is popularly known, graduated from IIT Kanpur with BTech in Meteorological Engineering, and he proceeded to the School of Materials Science and Engineering, McMaster University in Canada, for a direct PhD. And he returned to India in 1991 on invitation from the government of India to set up a unique self-financing R&D center in materials, and which is called NFTDC, that is Non-Ferrous Materials Technology Development Center. And he has been the director ever since the organization was set up in 1998. And Dr. Bala has guided many PhDs and has over 100 papers to his credit. So without any further ado, let me invite on stage Dr. Bala.
It's up to you. I have no issues. I can stop anywhere. I was asked to increase yesterday, so I increased, so it doesn't matter. So, okay, so next 20, 30 minutes, I'd like to take you through a solution path for the development of drives. I've been involved in setting up centers of excellence in EV drives, energy materials, bioengine, ITER, and a number of things in the last 2 decades. Last 6 years, we pioneered many things in EV systems as early as 2007-8. But why did we do it, and how we did it is a quick story, and let me take some extracts out of it and show you. The most important thing is that there is a paradigm shift, there is a DNA change, and what I would like to take is a systems thinking and how to think from top down rather than bottom up. And as you wish. And that's why, and I have to run a self-financing center. It's very simple. The money giver is the king or the queen, and that's it. And so we are an invoice-based, project-based organization. So we have to always be at the product or something that is up. So we have to link up all the bottom core competence. What happens? What do you want? Okay. So I borrowed the first 5 slides from Larry Burns. Is it working or not working? I'm getting disturbed with it. So I've taken the first 5 slides from Larry Burns of General Motors, and this is what, when I had a meeting with him in 2004-05, and they were trying to get me to start their center in 2002 in Bangalore, and well, I didn't take it at the time. But anyway, the issue was the DNA has been the same for 100 years. So the DNA is the basic genes of the propulsion system, and that has changed, and the propulsion has changed. The more important is the vehicle electronics and control has changed. I mean, it's no longer mechanical control, it's the software and the logic that controls it. There are a lot of other connected vehicle technologies that are enabling things, and advanced materials came into being. So they said that, look, now we don't have the combustion-based systems, so there is a fuel which is substituted by a fuel stack, hydrogen-based, but you have to store the hydrogen, so we need the carbon-carbon canisters. That's a connected technology that has to come in, and there is an electric traction. That was the first solutions set of technologies that came. So this is the way it progressed, and they asked the young engineers to design it, and they came up with a skateboard, and that was called autonomy at the time. The first vehicle that was designed was the autonomy, and the vehicle was only 18 inches tall, and it did everything that the car is supposed to do. So they have to build the rest of the structure because people are used to steering and all those things, etc. So this is how finally everything was put together, and you can see nothing much has changed since then. Right? This is This is how the DNA is. So anyway, there are a lot of things, autonomy, then SQL and all those things. Everything was low chassis architecture. I mean, that's the message that I would like to give here. And a lot of other connected technologies came, and the most important thing was it had only 1/10 of the moving parts. And, regulation was almost, you don't need to, I mean, it's almost, the emissions are not there, and et cetera, et cetera. But the whole thing had to handle, the vehicle dynamics was much better because there was much more electronic control. Anyway, this is the background. So this is what took me in, because when I discussed with him, in fact, the day was a very interesting day. It was a 9/11 day on 2001 when he came to my place, and he offered me the big job, but I didn't take it at the time. But I was telling him, forget about it. What are you guys working on? You'll look at what I could. So that's how I got introduced into EV as early as early 2000s. So I created this center, spearheaded it, which is a technology center, technology and science. If you want to ask somebody in an interview and then see how they answer, you'll get all funny answers. But the simple answer is, science is knowledge creation, technology is knowledge integration. A lot of things have to be brought together in a system. So having specialized in thermodynamics, energy, so I keep counting every calorie and every joule. So in the last 20 years, I created a lot of centers of excellence. We started with advanced materials. This is an integral differential paradigm. And we are in aerospace and biomedical, which is advanced engineering design, and this one. So that has already brought us to electric drives. And of course, when you are in materials, you can easily also graduate to energy systems like fuel cells, batteries, capacitors, etc. But we are not into all of them, we can say. So what's the problem for today is this. We need to do the transition, and the transition is full of catch-22s. If we don't get into manufacturing of EV components, we will not be in sync. So we will be giving away the market to imports, and our EV and our automotive market is one of the strongest markets existing in the conventional sector. And if you look at the transition, our tier 1, tier 2 is very well established. It's a large contributor to GDP. It has a very minimal import content, and it's export sector. The present sector is also an export sector. Now that is shifting to go to imports, and manufacturing base will take 5 to 10 years, and we have to quickly adopt, develop, import technologies and see and graduate. This is the problem that we have at our hand. Now the problem is we are switching from fossil fuel, which is in operational cost, to capex in the battery cost. That's the shift that is happening. So cost of money is very high in India. So that's not going to happen that easily. And the import depends on just shifts. I mean, that's basically the issue. But what is the SWOT analysis? If you look at it, yes, we have a market pull in two-wheeler, three-wheeler, and buses. We can ramp up the motor controller production, but our weakness is energy per kilometer is very high because of the roads, because of all these things. Our weakness is, if you look at it, our strengths of others. Our weakness is matching with the strength of others. That's the most dangerous situation that you can get into. So, yes, if you have an L1, you can easily win tenders and swap you out. And that's the problem, because we have the way in which the partnerships the OEMs have to have with battery manufacturers or in-house battery manufacturing. So these are the things that has to happen, and they will take 5 to 10 years. So we have to be ready at least for 2025, 2030. So what I want to talk about is this: what is the strategy, what is the solution base? Now, can we do development in India? If we have to do development in India, we have to go through the whole chain of translational R&D to setting up commercial entities. So what I would like to present is we need to design vehicles, solution drivetrains specific to India. That means our drive cycle or these things. And then we need design for manufacture, and we need strategies for enabling drive component manufacture, motors, PUCs, battery. I put it in green, blue, and yellow. Red, green is under control, blue is ongoing, and red is in deep trouble. So let's see what is this. So this is the summary of it. If you look at it, We have the motors, controllers, battery, BMS, charger, DC-DC and DC-AC, which are the subsystems, and we have mechanical, electrical architecture, and big-time thermal management issues. That's the issues that we handle together, go for a vehicle-level integration. So what is green is under control, what is blue is ongoing, what is red is in trouble. Okay? So that's the quick way to put it together. Now, how do you do it? See, what we said was, well, if you ask an OEM, they'll say, okay, find out where the motor is available, and let us put together a system and see what happens, right? But we said we'll do it the other way around. We said we'll start looking at what is the drive. I mean, how does a vehicle move? Finally, our job is to move the vehicle as a drivetrain, right? And for that, the prime mover is the motor, which has to be controlled. It's like a husband-wife pair. I'm not going to debate who is wife, which is husband, but anyway, so they have to be together. We can't have a divorce situation here, so the controller has to control. And something else has to give the energy. Let's worry about how to get the energy. That's the battery part of it. But can we model the whole system? And if you get the whole system, and in thermodynamics we say entropy reduction is possible only with energy and with knowledge. Knowledge is negative of entropy. It's a direct mathematical relation. So if I increase the knowledge content, which is the information relationships, data and information have no use. The moment there is a relationship between sets, you have use. So that's what we planned to do, and we did it. Now, this is what a drive cycle-based analysis work is. Now, what is meant by drive cycle-based analysis? It is a very simple energy calculation. Mind you, this is the energy that I am calculating on the axle shaft. This is what we call as the energy demand, this thing. And force is a vector, energy is a scalar, and if you take the gradient of energy, you get force. If you take the integral of force into distance, you get the energy. That's the relationship. Force is gradient of energy. Energy is integral of force into distance. So I have force, and there are four forces. There is a drag force, there is a friction, there is a rolling resistance, and finally I need mdv dt. And if I cross a dot product it with velocity or speed and integrate it over time, I should get the total energy. So you can easily do it, and finally when you do it for a bus, you get the number 1.08 kilowatt hour per kilometer. So wherever you see the positive slope, it's acceleration. Wherever you see the negative slope, it's deceleration. You have a potential to regenerate from those negative slopes. But anyway, that all depends on the vehicle dynamics. But you can do this fully. We can measure it. We can actually determine it. You can do the same thing for a four-wheeler, which is 1600 kgs, this thing. But I will show you what Praveen and I have been trying to do. So what is, we have a big consortium for two-wheelers and three-wheelers. I initiated that consortium and I lead it. The important thing is that we don't have drive data, cycle data for two-wheelers and three-wheelers in the country in our metro. So we created it, and this is a typical Guwahati drive cycle of 1920 kilometers. And we have the vehicle parameters, coefficient of resistances, gravity, density, all these things you put in. And you see over a week, morning, evening, Monday, Friday, you have various patterns. It is just signal, and from that we can extract out what should be the force, accelerations. And with that, you get what we call as the operating points of the vehicle. Now, once you have these operating points of the vehicle, you see what is the solution that we can give. You just don't design a motor for the highest operating point, which is what the IC engine did. And second thing is, there are creeping cycles. We call it as three cycles. Creeping cycle, economy drive, and sports drive, right? The creeping cycle is you are stuck in the traffic and you are going bumper to bumper, and at that time you've burned, whether it's electrons or fuel, it doesn't matter. Even your battery will get discharged, you would not have even moved much. So we need a different solutions. Is gearing a solution? Is dual drive a solution? Like that, we need multiple solutions. So we have hundreds of solutions we have come across for various vehicle segments. So I was kind of pushing him 2 years ago, 3 years ago on it, and now we have, across the country. You do that for all vehicles, right? And then I created a quick ready reckoner table and said, first column you'll see is what is the kilowatt hour per kilometer for various segments of this thing. So higher the size of the vehicle, okay, it'll consume more. But if you need 100 kilometer range, you can get 80% DOD, so you need 1.2 times the energy required for the battery capacity. And you can see that, look, I need 160 kilowatt hour battery minimum. If I want about 100 kilometer range, I need 2.5 kilowatt hour battery for a two-wheeler. But that's not the story. The story is what is a fraction of that with respect to the total vehicle cost. The smaller the vehicle, the larger will be the proportion of that. So we have solutions here. Now I am going to give you another scary data. Now what is the beauty of this gasoline is that its volumetric energy density is very high. It's 32 megajoules per liter. And I've given you other hydrogen fuels, which if I go for a fuel cell, I need to look at the hydrogen part of carrying it. And so that's the comparison. So I'll give you quickly energy content and cost of energy. So, but you need a conversion factor. 1 kilowatt hour is 3.6 megajoules. So 1 liter of gasoline gives you 32 or 9 kilowatt hour of this. 1 kg of lithium battery will give me 0.15 at best. 0.12 is typically that, 0.15. It's 0.54 megajoules. So 60 kg of battery is equal to 1 liter of gasoline. Now I start the design now. Now, but luckily I have one advantage in battery. IC engine efficiency is 0.27, EV efficiency is 0.81. I have taken 0.9 into 0.9 as 0.81. So at least I have a factor of 3. I deliberately wrote 0.27, 81 so that I can divide. 3, so that means 20 kg of battery is 1 liter of gasoline. But the problem is not that. Capex energy, 1 kilowatt hour costs me $250. We hope to $150 will come, but I don't know what the exchange rate will be at $150. I'm going to lose anyway. It's $25,000 to $30,000. So, and if you look at the cost of that energy today, petrol cost is 72 rupees. It's 8 kilowatt hours, 8 rupees per kilowatt hour. It is same as 1 unit of electricity. It is not that electricity is cheap and petrol is expensive. Even at 72 rupees, petrol is still cheap. Even at 30% or 0.27 efficiency, it is still good. All right, so let me summarize all these things. I convert it now in another route. Now, how much energy I consume per kilometer. So look at that line. For example, in IC engine, it is 8 megajoules. In EV, I should come down to 3.7. That's my only advantage I can think of. If I can push the EV bus to 0.8 kilowatt hour per kilometer, which is doable, if I know the drive cycle very well, then I can bring it down to 2.5 megajoules per kilometers. Yeah, 0.9. So that's basically it. That means if I know the drive cycle, see, if the same bus, the bus I put it for an airport route and a bus I route it for another route should not be the same. So that's what we are trying to answer. So let me start designing it. 1.08, you see on the right-hand side top. Well, I need 250 kilometers, so I need 300 kilowatt hours at 0.9 efficiency, which is very high efficiency. I'm not going to get 0.9, I'm going to get 0.81. If I get, I'll be happy. So that will translate to 375 kilowatt hour battery because I can only take 80% of the energy of the battery. So that's 3000 kgs of batteries. Not a very happy situation. So can I add another energy source, fuel cells? So my 375 kilowatt hour battery, I can reduce it to 100 with just a 25 kilowatt hour, another fuel source. So this is what we call a system level modeling based on energy demand. Right, I can even go, we were talking about SOFC. So SOFC, so I've taken a very, so we have to talk about what is the energy draw per hour. It is not only per day, 240, 250 kilometers. Per hour, how much am I going to draw? And how am I going to meet the demand in per hour draw? So 240 kilometers, that is 15 kilometers per hour into 16 hours a day, 240 kilometers it will do. That means the average speed of a bus is 15 kilometers per hour. This is the actual thing we have measured. And 16 hours a day, 240 kilometers. So I wrote 1.08, but that's at the wheel. It will be 1.5 at the battery demand. So per drive cycle, after, I need 25 kilowatt. If I have to get a battery, swapping, keeping everything, the lowest I can do is, if another battery is available, I should have at least consumed 25 kilowatt hour and put another one, or now typically 50, let's say. So this is how you start doing the design. Now if I add the fuel cell plus 100 kilowatt hour battery instead of 375, energy from the battery I draw, let's say 5 kilowatt hours only. Rest 20 I am supplying from the fuel cell. But my charging time is 9 hours, so in 15 hours I am drawing all this energy. So I do a simple calculation, 100 kilowatt hour, I draw all of it, 7.75 is what I can draw, which I can recharge, and every 3 hours it will discharge. So I need to swap every 50 kilometers. If I put a fuel cell of 20 kilowatt and then draw only 5 kilowatt hour from the battery, well, I can go to 15 hours of run. And if I do 10 kilowatt from the cell and 15 kilowatt from the battery every hour, then I'll get about 5 hours. So you have to do this energy dynamics in real time. It's energy draw per second is what I need, rather than just the total range or total this thing. That's how you start doing a system design from the energetics perspective, and therefore what is the challenge, what is the solution. So reduce a specific energy demand. Don't ask for more energy, that's the problem. That 0.9 goes to 1.2 moment you put air conditioning. The power steering takes 0.05, lighting, this, that, I can tell you. So put as many as those things on another non-traction load. You can even carry a lead acid battery to do that for a power steering, So you should not put it on a traction drive. So reduce the speed, max speed, because everything, drag, friction is all V squared, V cubed. So if the real drive cycle, it has never crossed 50, why do you design for 70, 80? And if you are designing a bus that is going to run inside the airport, 20 kilometers is the max speed. So that is what it is. And we develop designs with dual drives, etc. And the controller is next generation controllers. We have done many of those things. And understand the regenerative capacity in a drive cycle. What is your purchasing power on your negative or deceleration part of the cycle? So it's completely drive cycle based. And if you do that one, now you're going to supply that energy in demand in real time. So we need to optimize the energy source. So understand the rate of draw of energy and its variation in the drive cycle. I need the battery current, I need the energy every second. And understand it. And more than one source to reduce battery sizing. Fuel cell, hybrid battery which is capacitor plus, or a strong hybrid IC engine plus EV. So India does not require a complete EV solution. It's not the good answer. I'll give you the swapping, particularly for three-wheelers and e-bus is possible. So what is the summary of this? Different horses for different courses. Be technology agnostic. Percentage of electrification should be determined real time as per drive cycle demand. So I'm talking series, parallel, combined, hybrid in real time. So it's logic that controls it now. So let me talk another possible way of doing it. Okay, let's say, let me compare various degrees of electrification that you can consider between a fully battery EV to an IC engine. What is our biggest problem? If I put a vehicle today, a car or something, the cost differential is 6 lakhs. 6 lakhs comes from simple 25 kilowatt hour battery into 30,000 rupees a kilowatt hour, 6 lakhs I have to shell out. So if I compare it high versus nil, for IC engine it is nil. I am comparing with IC engine vehicle, a vehicle. Range is 100 kilometers versus 400 kilometers. I fill the tank, I am going 400 kilometers. It is low versus high, which is again bad. Fuel cost is, it's almost the same. So what we need is that we need low, medium, high combination. This is what I called it as CRF factor, which I introduced, cost differential range fuel cost summary optimization. If I do that optimization, I need some basis. So let's say I run 25,000 kilometers a year, and I'm going to take 1 million vehicles. What is the tab on my fossil fuel import? What is the tab on my battery cost? IC engine will give me 15 kmpl, mild hybrid 17 kmpl, 10% it will improve. Hard hybrid 40% it will improve. Toyota Camry has proved it. PHEV 35 kmpl. So I should develop 35, 40 kmpl vehicles. That's all I should do. I would have knocked down the fossil fuel bill in a big way. Do I have to do it with 100% electric? Okay, let us put it. So let us take all these values and then say, go one by one. What is the reduction in fossil fuel consumption? If I put a fully battery operated vehicle, 100%. I don't need it. If I put a PHEV, 85. If I put an IC engine, it's 0. If I put a mild hybrid, 10%. Now, if I do a hard hybrid, which is the most important, I get 40 to 50%. That means if you go to the net fuel import, if I have, let's say I import I make 1 million vehicles, 1 million cars, if it is all IC engine, I would have spent 1.7 billion liters to cover that 25,000 kilometers, over 1 million vehicles. Whereas if I had done hard hybrid, I'll do only 1.0. I get 1.7 to 1.0 is my reduction in my fossil fuel bill. And like that I carry on. The capital cost differential is what I have to do. I have to bring it within 1 to 2 lakhs. If I bring it within 2 lakhs, a cost differential, I've written 1 lakh there, but it's a little ambitious, 2 lakhs within that, people will buy it. And therefore, I started ranking it. That is last but one row, if you see it, penetration potential, cost differential, plus range, plus fuel save. When I say fuel save, fossil fuel save, the rank is number 1 for hard hybrid. In fact, the rank is 4 for BEV. Because what I get by making 1 million EVs, I can get by making 2.5 million hard hybrids. The net benefit is the same. Whereas I can sell 2.5 hard hybrids, I will not be able to sell 1 million EVs. So the penetration will be higher like that in this one. So I presented to Niti Aayog, I said, reduce the damn GST on it and giving that, give another incentivization. That was the last row. That was what it is. So anyway, so this is the energy demand, energy source optimization, etc. So I ask Praveen to do electromagnetics more and more. I said, I will look at the energy more and more. So we are doing some song and dance choreography these days. Let me see where it takes us. So anyway, but motor design is a system level design. I just wrote only one equation. If you know how to calculate torque or force, you come into this domain, otherwise don't come. If you cannot rotate vectors in your head and do vector algebra, it's difficult. Its force is BIL, where I is current, B is the magnetization, L is the length. But it's actually it's a multiple domains. Thermal is a big deal. Advanced materials like magnets or laminations and whatnot, and casing, and then vibration, shaft, insulation and whatnot. Finally, what is our job? Our job is to see I don't draw much current from the battery. My battery current has to be low. But at the same time, I have to pack more energy into the motor, so my motor size has to become small, so which means that something I have to operate at higher voltage, something else is at lower voltages. So I had to do a lot of PECUs in the middle. So a few years ago, I did a map for all the motors. Anything that moves is because of motors. It could be a small hard disk sitting in the computer rotating at 30,000 RPM with almost negligible torque, to a railway traction which is at very high torque, high HP, and very high RPM. And there are fractional horsepowers like our domestic appliances like washing machines or air conditioners, whatnot. So those are all yellow. They can all operate in a single RPM. But we need a range of from almost 1 horsepower, from 10 horsepower to about 200 horsepower range, and over a wide range from 1,000 RPM to some 10,000, 20,000 RPM, we need to operate a drive. So what do we need? We need a lot of attributes, and I'm not going to go through it. I just want to say that high torque, low speed, and how to get high efficiencies in that region. That's the real design problem. And we need a very fast torque response. That's what the controller has to do. And we need high efficiency over a wide speed range. So we should not talk efficiencies at one point. We need an efficiency map, and that's what Praveen is also doing. So we came up with drives for all the segments, and this is the total segment. If you need to do a two-wheeler, typically sit around 1.5. Sorry? That's what it is. That's what I asked you, whether I do 20 or 40. Fine. So I'm almost close, and I'll probably... Huh? No, you have to tell him and tell him. How much I take more? You give me how much I can borrow from you. Give me a hotspot. No. We'll do some energy partitioning. We will take 10 minutes of your time. Fine. All right, sir, 10 minutes. Okay, again wave your hand, okay? All right, so this is the reference vehicles. So we give it to the designers, look, design around like this. This is what it is typically. So there is no point designing all kinds of things. You leave it to researchers, and so they will go all over the place. No, I have done 4.1, or 5.5. We need a targeted things. And this is the typical motor drives we have. And the most important thing that I would like to state is we have to control it over a range. And whereas a conventional motor, the efficiency is at 1 point. It is designed for 1 point. So here it has to do at all points. What is more important is this. If you have permanent magnet-based motors, we have a supply chain problem. We have a dependency on China problem. And more than that, our exchange rate is going to kill us. Anything else, any good thing you do, finally exchange rate. You talk $150, and if my exchange rate goes by 20% off, I have lost it. So we need solutions which are predominantly magnet-free. We'll also have PMSM to compare. If somebody can afford it, yes, take it. So we mastered the induction drives and synchronous reluctance drives from low to high, and that's what it is. So there are advantages which are in black. It's very high energy efficiency, synchronous reluctance, and it's a familiar induction motor is robust. DOIL start is available, but lower efficiency at lower speed, slip losses, torque only in asynchronous operation. So can we do it without sensors? These are the challenges. The red one were challenges. Then in a synchronous reluctance, it's a low power factor, but there is no magnet, there is no copper. We are only using steel to do all the job. Typical PM motor, yes, we have a problem of magnets and costs and whatnot, and etc. So synchronous reluctance was coming out as a very, very big option. So we were one of the early starters in that, both switched and reluctant drives. So the principle is very simple. You match the slots so that the magnetic flux path is aligned. That's the basic fundamental. It's a very old technology. So we have started doing the bus motors, and we have started doing as low as 1.5 to as high as 120, 130. So this is already in our test bed. There's 67 kilowatt and 120 kilowatts. But what I would like to state is that the slot designs are very difficult here. But that's not our problem. Our problem is we have to do design for manufacturer. I can do a very fancy slot design based on some beautiful electromagnetic optimization, but I can't make the dice to make the punch and get the laminations done. They'll become very expensive. So just to tell you that how the torque ripple, maximizes here, just because I put a notch for something else, that is to keep the stack together. We had a notch, but that increased the oscillations. So we started optimizing all of those things, and we got our drives done. That one. Now the controller it's on the test bed with the controller. Like that, once we have done the drive cycle to design parameters, to design optimization, now we go to manufacturing. So we need to do hundreds of designs, and also going to provide a lot of numbers also. So I set up manufacturing base for it. So we can't make dies every day and every small iteration. So we have a very high-end state-of-art laser laminations. And we also have to do thermal management. There is a very big thermal heat evacuation and cooling design solutions that we had to bring in. So what we did was we had precision laser lamination. You can't do a CO2 laser, or we can't do any other cutting laser to do any of these laminations. It will fail there miserably. We need high precision, and we should not have any burr. So it's a total nitrogen laser which is oxygen free and high speed with very high precision. So because of that, we were able to do n number of designs we could validate and come out with a solution. We also did, for induction motor, very high efficiency, went into copper die-cast rotors very, very early on. We are one of the pioneers in the world, and probably only one now other than Korea, China has, and we have it here. We can do from very small to very large. This thing is a very, very typical. So that means from design to manufacturing, we have to bring in a lot of innovations. And we went up to the motors, and we are now giving the motors. In the next 5 minutes, if I may be given, I'll complete the power electronics and close. See, power electronics is one I diagnosed 10 years ago as being pathetic in India. First, they are second-class citizens in the departments. I can tell, I'm an outsider, I'm a third party. So it's all communications, distance signal processing, that was there, and very, very difficult to get people in electrical machines, designs, and power electronics, which is really the need. And we don't have electronics manufacturing in the country, and power electronics is even worse. Okay, and so 8 important devices has to be done. Important one is the controller, which is very, very high end. We need generators also we need on, because both regen and other generation. We need battery charging, and we need converters. The top 4 are very, very important. But we also need other things. Many support things has happened in a vehicle. Those rest of the vehicle is not going to go away just because we had an electric traction. The wiper has to work, the lights has to come on, the power steering has to work. So there is a lot of power, and there is a lot of different kinds of things, compressor, blowers, whatnot. So we need AC power and solenoids, controllers. Hybrid battery control is when you have a capacitor and battery pack equalizer and BMS. So this was the conventional route, that you have a logic board and the power board. Something that can sense the state of the system, and you have a control board which does the logic, and power board starts giving the pulses. Now what is the problem here? The problem here is basically this. You can take bits of information and send it across to Pluto. But you can't chop the energy into pulses and send it across 1 foot. Even moving 2 feet is a big deal. So this is the difference between communication of information and data and transfer of energy in pulses. You see, you take the carburetor, the moment they got atomized droplets of fuel injected electronically in pulses, they got better efficiency even in an IC engine. So we need to chop energy and give it as per demand in real time. Now I'm getting it from multiple sources of energy, I have to do it in real time, and that's what I'm going to do. So these are all the hardwares that we developed. I'm not going to go into it, but I'm going to give a conclusion to it. Sensorless and system design based, I mean, they call it as DTC. I have coined a new term, system design based controllers. The controller has to be for a particular system design. You have fuel cell plus this, you have capacitor plus this, you have this plus this. I mean, so let us have different horses for different courses. And then controller for multiple energy sources. It will not be one, so I have to calculate how many droplets go into the IC engine, and as well as how many electrons move across here. I have to do this, and I have to do it for Indian drive cycles. So last 3 slides to summarize. Number of parts are going down, so we get into flexible manufacturing. So a part manufacturer also can become an OEM. That opportunity is this. Power electronics, 8 devices are required. I identified each of them with ratings, with semiconductor devices, with control logic board, etc. Software content is very high. In fact, it is so high that we are all scared. But it's also good. It takes the, you can't make such decisions of how much to press the pedal, how much not. It will calculate and do it. You just are giving only one action, it will do it. And thermal management solution is very, very big area which is untapped. Charging devices, we need India-specific solution. It's a big opportunity. So this gives me, this flexible manufacturing allows me to do multiple segments of specific drivetrain. Today I'm doing Upma, tomorrow I'm doing dosa. It's like a kitchen now. We can bring the flexible manufacturing to do many things. And direct marketing and worldwide customer base is possible now. When if I start something today, I don't have to be married to a tier 1. So the way in which the tier 1 has grown in India is, they were told by tier 1, by OEM, buy this equipment, here is, make this part, and you give it to it at this price. This is how they were fed and nurtured. But today, it need not be. Shift in ownership, the vehicle ownership is moving now. And shift in business model itself, that's what Seshu talked about. Pay as you use business models will come. We're already on the way. So that's it. So how do we take off? Last slide. Fastest retrofit and conversion market will also emerge, which is the best learning curve. And flexible manufacturing. And we need to develop design expertise. Thank you. I will not go into batteries, which is another 10 slides, so let me leave it. I have a solution for battery also, but it's not the time now.
Thank you, Dr. Bala. May I request you to be on stage? Thank you for another very interesting presentation, and indeed, different horses for different courses. One size fits all approach will definitely not work here. Now I would like to invite Dr. Praveen Kumar to felicitate Dr. Bala. Thank you very much, Dr. Bala, once again. Our next speaker of the day is Mr. Ayush Lohia, CEO at Lohia Auto Industries. A quick introduction. As I mentioned, Mr. Ayush Lohia is the Chief Executive Officer of Lohia Auto Industries, and an automobile company that offers traditional as well as green energy mobility solutions. Lohia Auto Industries is part of the diversified business conglomerate Lohia Global. Mr. Lohia has around 20 years of experience and almost 10 years of them in the auto sector. Before joining Lohia Auto in August 2008, he spent nearly 9 years in different companies of Lohia Global, leading strategic fronts and fostering engagements with brands like Walmart, Tesco, IKEA, Pottery and Barnes, Target, and others. As CEO at Lohia Auto Industries, Mr. Ayush is leading the team and provides thought leadership, vision, strategy, and roadmap to enable Lohia Auto's product and business strategies across national and global markets. Over to you, Mr. Lohia. Can we get some help here, please? You don't have
No, I don't have a presentation. So, good afternoon, everyone. As a brief introduction is already given, I am Ayush Lohia from Lohia Auto. I don't have any presentation to showcase anything because between guys like Dr. Bala and everyone, I think give anything on technology front is my stupidity, which I don't want to do. So I'll talk on more on the commercial side of the vehicle, and I am from a commercial side person. So let me talk and brief you what actually the topic of today's is how to create a nationwide EV ecosystem in India. Before that, I'd like to thank you, Autocar Professional, IIT Guwahati, to giving me this opportunity to come and speak few words about you, about the industry. So to start briefly about ecosystem, what kind of ecosystem are we talking about? What exactly electric vehicles are we talking about? And who has to own the responsibility for taking this ecosystem to the next level? This is the foremost, the most important question comes into everyone's mind. At last, we are talking about creating a shift, which everyone is talking about, taking a shift from IC engine to a battery electric vehicle system. And we are talking about it industry in which millions of people have been employed, and we have a GDP of more than 8% of India's total GDP. So we are talking about a shift which is going to affect millions and billions of people. Rather, I'll say everyone is directly or indirectly going to affect from this shift. So we need to be cautious. We need to be relatively, testing waters well in advance before we come to a strong shifting this complete ecosystem. So this shift of ecosystem can only happen if all the major key stakeholders come together. Stakeholders in the form of whether we're talking about the government, the technology front, the institutes, the salespeople like us, and even the user. User also need to be aware about the same before we bring this shift in ecosystem. So here when we talk about an ecosystem is about the product, about the sales, and the infrastructure. These are the three key ecosystem parameters in which I have divided this complete ecosystem. When we talk about a product, we need to start with technology, which Dr. Bala and Dr. Seshu has been talking about each aspects of technology. When we talk about the battery, the BMS, the controller, the motor, the n number of calculations which has to go through it. I was thinking that I was sitting in a classroom way back in my 8th or 9th standard, because at that time I've studied physics, suppose that I have not studied. So I was feeling very interested to learn more about the vehicle, because I'm not that involved in R&D further on that front. So that technology is very important. After you have come to a conclusion of developing a right product technology so that you can take this forward, you need to design, incorporate the need of the consumer. You need to put the heads together what the consumer wants, rather than giving a consumer that what we can develop. There's a hell lot of a difference when we talk about what the consumer wants and what we develop. We can develop a product which can satisfy our need, can be the best suited to our requirements. But frankly speaking, when we go to the market, we find that actually the customer is requiring something different, which we have developed. So we need to design the product as per the customer need, create the complete supply chain ecosystem. Very rightly said, you need to have the right people in place to manufacture the technology, to manufacture the design in a cost-effective manner. Otherwise, the complete exercise of creating an ecosystem can go haywire. Dr. Bala has been explaining about how the price difference is going to affect the complete vehicle. And we are talking about an industry, the country in which the price sensitivity is so high that person can change a decision with a change of even 5% differential. So we need to design the product with a cost-effective supply chain system so that a quality product can be outsourced or can be created and productionized in the complete by the OEM. So when we talk about the product, we are talking about the technology, we are talking about the design, the supply chain, and the right quality. Every aspect plays a very important role. Any one aspect missing will, affect the complete ecosystem. If we don't have right quality, right design, the technology, that's why it is taking so long in getting the ecosystem in place, because we have not started scratch. We have recently thought about we are just putting the things together from different parts of the world, trying to, do a lot of trial and error, see what can work well for India, everything. But we have to change that thought process. We have to think taking into consideration need of Indian consumer, putting together every effort so that we can come up to a product which can be useful for consumer, who is at the end of the day, the consumer is to drive the vehicle, who has to go from one place to another. The effect is very small, but the head or strong which has to go at the back of it it's a widely effect. Then the second ecosystem which plays an important role is the sales. When we talk about sales, it's not about only creating, selling the product from an OEM to a consumer. It is about creating awareness, creating a network of service, creating a network about awareness among the consumers, creating awareness about how to use the product, what best can be done, what is the best possible opportunity, what is right, what is wrong. Again, from the perspective of each and every aspect of the sales aspect we have to consider before we reach to a certain point. The second most important aspect in sales is retail finance. This is something which is the most important change. In today's scenario, no consumer, or I'll say almost 95-99% of the consumer go for retail finance. This is the most important change which is missing in the current scenarios. Even when we are talking about, I am present in in electric vehicle industry from last 10 years. We started Loya Auto with electric vehicle two-wheelers, and even from last 10 years, we have been running from pillar to post in every area. Retail finance is the biggest challenge what we face. And without overcoming this retail finance, I can tell you, whatever product we design, whatever product we produce, if we are not able to satisfy a customer need, you will not believe a consumer comes with only 10% as a down payment. Rest of the even when they are buying an IC engine. So that area need to be addressed very well. Then only we can see the complete ecosystem chain to be successful, because retail finance is an important area, and that area is, again, it's hard money, how to lose that. So addressing those challenges has to be important to see that performing. The third most important area is infrastructure. Think about, you have a gasoline vehicle and you don't have petrol pumps. So we are talking about a product which is there, which can be used in a day-to-day life, and we don't have a petrol pump. Think about petrol pump goes on a strike. I think there was this thing happened almost a month back in Delhi, and it was heavy. The roads were looking deserted because people don't have anywhere to refuel them. And we are talking about creating an ecosystem without creating an infrastructure like charging stations so that we can drive around. So infrastructure has to be there. How we can create a infrastructure, either using the charging system or doing a battery swapping. Again, both of this has a pros and cons. Charging infrastructure, time is an important challenge. No one wants to wait in today's scenarios. Time is money for everyone. We are not able to even wait for getting into the queue for the petrol line. And we are talking about minimum, even today's technology, what is available is, yes, there are areas where we can charge in 10 minutes, 15 minutes, but actually what is commercialized is only 30 minutes to get a full, an hour, 60 minutes to get a full charge. So no one is going to wait for that. So the alternative comes with the battery swapping. But battery swapping has its own constraints. Battery swapping can't be done for big vehicles like buses, cars, and everything. It can only be done with two-wheelers and three-wheelers. So those kind of challenges has to become. And who will take a call for creating an infrastructure? Is it only government? Is it only an OEM? Or is it only the consumer? Actually, if you see, every person has to pull in to make this ecosystem work, whether on the format of a product, whether in the format of sales, whether you're in creating an ecosystem or our infrastructure. Then only if all these three put together can come into a basket, then we can say, yes, we are starting or looking to create an ecosystem. If any sub-part of any of these parts are missing, I don't think so we are creating an ecosystem. What we are doing at the end of the day, we are expending our time, money, everything, bits and pieces, and we see that nothing is happening on the floor. We need to come together to create this ecosystem. Without that, I think we are all wasting our time. What I can only say from my perspective, maybe I am biased towards this, a lot of people say at times, but at the end of the day, what we see today is what is the most important low-hanging fruits what I find in the complete ecosystem which can be shifted. I find two-wheelers and the three-wheelers as the most important and the aspect where we can cover the transportation of people, where we can cover last mile connectivity, where we can cover even creating employments, and still can move people. So I find, as my personal perspective, that two-wheelers and three-wheelers can act as a, the easiest form where we can create this ecosystem faster. So I call them low-hanging fruits. If we can convert good amount of vehicles from in two-wheelers and three-wheelers from a IC engine to a electric vehicles, I can say we can start an initiative doing that. Bus requires a lot of investment on creating things. Vehicles like four-wheelers also requires a lot of investment. A lot of people has to be deployed. A lot of infrastructure need to be developed because again, we are talking about money and every aspect. Every component is expensive. We are definitely seeing a trend that as the production will grow, the costs of ownership of the vehicle will come down. But what we find from low-hanging from two-wheelers and three-wheelers is we can easily shift. We can easily commercialize. 85% of the total vehicle population is two-wheelers and three-wheelers. It's a huge number. If we can shift even 10% of them, we can start seeing it from 2020, then we are going to see a major change happening. We can create awareness how to use an electric vehicle. You will shocked to believe that we don't have the right service people to be available so that they can service the electric vehicle. Every ecosystem can't be created overnight. It has to be spread over a period of time. So to create that awareness, we need to shift from a low-hanging fruits where we can find easily accessible. If we think about shifting an ecosystem to a high-voltage system, I think it's the most risky proposition in a complete format. When we say a low-voltage system, we are talking about 48-volt system, which is not hazardous to anyone. We are talking about a population and a person who can try to open every part by using a hammer and a screwdriver. You can't do this with the electric vehicle, especially with the high voltage system, which is above 60 volt or 72 volt. So creating that awareness and creating this shift requires time. And we can create that time by starting with electric two-wheelers and three-wheelers. We can create that awareness, what people need to take care when we are developing this electric vehicle and when we are servicing this electric vehicle. You will not believe, when we started in 2008, 2009, we were facing challenges to even educate people to make the puncture. We had to create whole lot of workshop videos to how to change a puncture in a two-wheeler. Can you believe it? Every hook and corner you can change a puncture, and you now think an electric vehicle where you need to, train the person to how to change a puncture, how to make a puncture. That's something very, strange, where the, education level is so low. Employment is so high. Everyone wants to take a risk. We don't care for the life. But at the end of the day, who will be blamed for? So we need to take a very constructive call. We need to look forward in a very motivation manner that we can create this shift. We can definitely create this shift. And very rightly said, we have hundreds and millions of people who are being employed to IC engine. Big OEMs have invested a hell lot of money, millions and billions of dollars. So let us phase it out. Let us create this ecosystem with the entry-level products from two-wheelers, three-wheelers. Let us take it to the next step. Bring all the factors together, product, sales, and infrastructure. Emphasize on each of them. And definitely we see a huge shift can be possible over a period of time. Putting a date or a number or a year that this can be possible to this is something which is frankly speaking need to be studied at a backhand in a much stronger format. In a small, like Dr. Bala almost spent 40-45 minutes just to talk about a few slides about motor and controller system. And we are talking about an ecosystem. So let us put together our hands, let us put our brains together, let us put our focus how to change the scenario. Definitely it can add a lot of value. We face every now and then the challenges about pollution, the challenges about, price hike in petrol, gasoline. We are talking about many internal and external forces which are impacting our day-to-day life because of IC engine. Let us shift to this ecosystem. I believe in this ecosystem, not because I am from electric vehicle, because I don't find any other alternative. So let us move ahead, and definitely I see that ecosystem once created will be a large impact on our whole society, every one of us. Thank you very much. Thank you guys.
Thank you very much, Ayush. Indeed, from your another perspective, after some very insightful presentation from two technocrats and very interesting perspective from you as well. And now I would request Professor Yamyavar to kindly come and felicitate Mr. Ayush Lohia. Our next speaker of the day is Professor K.N.S. Acharya. He's the Vice President and Global Head of Education and Competency Development and Global Head of Talent Acquisition and Immigration at KPIT Technologies. A quick introduction. Professor Acharya has over 32 years of wide-ranging experience spanning from industry, academia to applied research. Currently, he's a member of the senior management of KPIT Technologies, and as I mentioned, Vice President responsible for global education, recruitment, and immigration. Professor Acharya has a rich experience.
Good afternoon. I will not get into any technicalities because it's just a question of 15, 20 minutes that I've been given the slot. You heard Dr. Bala on the real technicalities that are involved in any EV technology. Now, what I'm going to focus on, as you can see the title, building an industry academia collaboration to the electric mobility industry. What do we need to do, right? And I will also briefly touch upon what we do as a company, and in bridging the academia and industry gap or collaboration, what effort has been made, which will be useful for young engineers like all of you. The entire auto industry is going through a major shift, right? It's probably an irreversible shift that we see. Number one, from the fossil fuel technologies to the electric vehicle technology is becoming a fast realization. Second is the technologies like the autonomous vehicle, the advanced driver assistance systems, connected vehicle technologies, and related problems that come up with the cyber security, functional safety. These are all the things that are driving the automotive technology. At KPIT, we are very thick and deeply involved in some of our customers in providing these solutions, both from a services perspective as well as from our own product perspective. I'm also very happy to announce that recently we had our own electric bus, which was indigenously designed, developed, and manufactured, which was inaugurated by our Honorable Prime Minister Narendra Modi. This first of buses which was given to the Parliament. Therefore, as I'm saying, what I'm saying here is, we know a little bit of this technology. It's a very vast technology. We have made our attempt as an industry to come up with an indigenous product which can be productized. We are working with Eicher Motors to take it into commercialization. A brief about our company, which I don't know how many of you know about who we are, because I'm coming here with two hats. One from an education perspective. Second, I'm also coming as representing the recruitment function. So I'm interested in having many of the young engineers come and join our company. So I will try to give you perspective on both sides. So as a company, we got incorporated in the early 1990s. We are about 37, 38-year-old company. And we are very much focused on three things. One is mobility, automotive technologies is our core bread and butter. We are an engineering R&D company with providing services to global companies, which you will see some of the companies with whom we work with. And the 4 areas which drives our technologies are, one is autonomous driving. We specialize on autonomous vehicle technologies, both in terms of software development, technology innovation, so on and so forth. Electronic powertrain and conventional powertrain. We are more focusing on electronics part of the powertrain, not in the mechanical part, which is software development, sensor fusion, so on and so forth. And connected vehicle technologies, which is both telematics, cyber security, etc. And vehicle systems, which is to do with vehicle networks, AUTOSAR integration, AUTOSAR validation, vehicle diagnostics, and cyber security areas. These are our areas of focus. We are not a manufacturers, we are more of a service providers, but you can imagine in the service space itself, there is so much huge demand of talent available, talent needed in the country. And the context that I am bringing to the northeast side of the country is, you have very rich talent in the universities here. Wherever I have been traveling along with my senior colleague Rakesh Prasad, who is also here, we have been traveling to multiple IITs and NITs across. One thing that we see is universities are still way behind what the industry wants in terms of technologies, in terms of the tools, in terms of the knowledge that the industry is needing. So that is where we are going forward and telling what is the need of the industry and how we can collaborate to make this journey happen. So what we do as a company is we build safe, connected, and clean vehicles. We participate wherever these 3 things are there, we participate in that. For example, when we say safe, it is to do with the autonomous driving algorithms, deep learning, machine learning, and artificial intelligence solutions, scenario creation of different scenario libraries across the world, feature creations and functions which will drive the autonomous vehicles. These are some of the fundamental things that we do. In the connected vehicle space, we have our own infotainment system platforms, integrated transport systems, AUTOSAR, which is driving the software development paradigm and standardization. On the clean energy, which is the context of today's discussion, we have deep expertise in the battery management system platforms, the software control systems and algorithms for motor controls. These are the things that are which we really specialize on. I'll skip this slide, and you can see we work with who is who in the industry. You name the big logos, be it the BMWs, the FCA, Renault, Nissan, Hondas, Volkswagen, Jaguar and Land Rover. These are all the companies. Why I'm specifically taking these names is we are probably the only company in India which has got very deep expertise in electric vehicle technologies, connected vehicle technologies, so on and so forth, working with the best of the companies in the world. Now coming to specific to e-powertrain, what do we do is we specialize on, I don't know how many of you know what is model-based system and software design. This is to do with, I'm surprised there are no representatives here from MathWorks. Of course, we have ANSYS equally competent on the model-based design space. Today, most of the activities that happen on vehicle system design, 90% happens on the simulated environment, both from fundamental simulations to all the way up to auto code generation to the software which goes into the cars, right? Earlier days, there used to be people who used to actually sit and write the entire C code, validate it, testing, and so the cycle is completely changing into a simulated world, right? Both MathWorks and ANSYS have fantastic solutions which are available in the market, but unfortunately, as an industry, we are struggling with talent who don't understand much of this. The content which is being taught in the universities is still way back in terms of the industry needs. Now, overall, in terms of industry and academia collaboration, coming to what we have done and what we propose to do is, we have a program called PACE, which stands for Program for Academic Collaboration and Engagement. This program was basically initiated about 4 years back recognizing the need that the auto industry, especially the automotive, electronics, and software industry, doesn't have the right amount of talent coming out from the universities. In fact, KPIT itself, we did not believe that some of the work that we do can be done by graduates coming fresh from the universities. We thought it's only a job of people with 6 to 7 years of experience, and we were bleeding money because any lateral talent that comes into the company, they come with a very high cost. Now, me and my other colleagues were saddled with the responsibility of setting up this academic collaboration with universities. We are today, I am very happy to say, we are partnered with around 20 Indian institutions so far, and we are taking this model to Europe as well as in US, whereby we have created certain contents which are needed for the auto industry, be it in the automotive electronics space, model-based design, be it in the AutoSAR. These are the terms which none of the universities have actually heard. Now, from an industry, we created this content. We gave this set of courses free to the university. Some of us who come from the academic background, we also went and taught these courses in the university. And thereby, the students whom we are taking into our company, they at least come with some level of preparedness to enter into the auto industry. That is our contribution in developing the talent at a national level. Now, the way it happens, it will be useful for IIT Guwahati also, is that we go through several cycles of activities that we do, which is identify the university partner, apply our selection criteria, connect with the university management, sign the MOU, create courses which are aligned to our industry, train the faculty members, and then bring in our partners also into the courses which are being taught in the university, so on and so forth. From 2014, when we were having about 40 to 50 graduate engineers being hired, this year I am carrying a target of around 1,500 engineers to be hired. It's a big shift, and that cannot happen until and unless industry and academia collaborate well to bring to a level of that we are thinking about. The second journey that we did in order to bring the talent is the global internship partnership. When I say global internship, it involves both India, Europe, US, and now in Japan. We have partnered with close to about 45 to 50 universities globally. And these interns, these global interns, they actually come and spend anywhere between 6 months to 1 year in our company. Normally, we have seen that internships are for a duration of 2 weeks or 3 weeks, but we have seen that this 2 to 3 weeks is of just it becomes an excursion. So we have said, when we spoke to many of the universities, they did agree for a semester-long or a year-long internship. And what these interns do is, when they come to us, we provide them exciting project areas, be it in the CS IT space, that is computer science and IT space, connected vehicles and infotainment systems, etc. You can see these are the kind of projects the students work on. We have an industry mentor and we have a academic mentor. And this really coaches and tests the technical expertise of the students. At the end of the 6 months or 1 year, nearly about 80% of them, they choose to work with us. Now, the internship model that we have established spans across both undergrad as well as masters, less of undergrad, more of masters. And again, this year, it could be of news to IIT Guwahati, we'll be taking about 300 to 350 masters interns, and who can spend about 10 months to 1 year with us, and at the end of that, we'll be absorbing them as our employees. So why I'm giving this information is there is a huge dearth of talent in the country for automotive electronics related areas, and we as an industry, we are making our best efforts to bring all of them together to develop the ecosystem. Otherwise, what we have seen is the lateral talent from they are moving from one company to another company, and their salaries are going high, but the companies are not growing. Right? Until and unless we build the ecosystem right from the university level, this mechanism will not work. And all the topics that I have mentioned here are extremely relevant for the electric vehicle ecosystem development. When I talk about ecosystem development, I am focusing mainly from the talent side, because until and unless you have the talent, you will not be able to give the right manpower for all the industries that are in need. Lastly, in order to ensure that employees who sign up and join us, we also need to provide them continuous education and higher education opportunities. We have come up with a very unique collaborative partnership with one of the premier institutions in UK, which is very next to our customer, Jaguar and Land Rover. Together with KPIT and Jaguar and Land Rover, we have been able to co-create. This is one of the best examples which has recently won an award, whereby industry and academia have co-created, co-designed, co-developed and co-delivering an automotive electronics master's degree program. It has all the contents of electric vehicle technologies. You have cyber security, you have machine learning, you have autonomous driving, AUTOSAR related. This is a very unique program where the content is completely jointly created by industry and academia. I think this kind of a model is very much lacking in India. I would sincerely urge the authorities in IITs and NITs to look at why can't they partner with Indian industries to develop. I actually went round from pillar to post, almost traveling multiple IITs. The knock on the door was not heard. Therefore, we had to go outside of India. But there are universities which are willing to work with us, and that's how we have been able to come up with this program. So here is an opportunity for people to co-create content for the EV industry. And we have made our attempt, and we are working very closely with global OEMs to develop the talent in India for Indian market as well as for the global market. And lastly,
electric vehicles, hybrid electric vehicles, and battery energy management systems have presented many challenges. With the evolving global industry standards, shortened technology development time to market, complexity of electrified powertrain systems, embedded control software, increasing functional safety, and the electronic control unit security requirements, architecture platforms are among the major challenges faced by OEMs and Tier 1s. If you are an OEM or Tier 1 under resource and time constraints in development of electric vehicle technology, KPIT can be your cost-effective engineering service partner for development of one or more imperatives of electrified powertrain and battery management system. If you are a manufacturer of batteries, electric vehicle components, or a system manufacturer with excellent hardware design and manufacturing capabilities, but see gaps in automotive software development and vehicle integration slowing down delivery to global markets, we can establish a partnership with technology sharing, reusable software architecture, software algorithms, battery plant model development, vehicle system, and software integration. We will help you deliver faster to markets. Here is why partnering with KPIT is beneficial. We bring extensive domain knowledge, technology, and product development experience in electrified powertrain control and battery management systems. This is a result of our dedicated investments in electric vehicle and hybrid electric vehicle controls technology development, battery chemistry, and characterization, as well as our long history of powertrain control and vehicle controls for global customers. We have strong product and technology offerings in AUTOSAR, functional safety, model-based development, cybersecurity, diagnostics development, over-the-air flash, and V2X communications and connectivity. State-of-the-art verification and validation methodologies in software-in-loop, model-in-loop, hardware-in-loop, vehicle and battery mechanical packaging design. We have patented state-of-charge, state-of-health algorithms that can be adopted for various battery chemistry and cell configurations. We have a...
I'll stop this because I hope you got a sense of who we are as a company and what kind of collaboration we have also established with the university. So the last, I think, industry and academia, we need to join hands together for a overall talent development in the country, and we are up for it, right? Thank you so much.
Thank you very much, Mr. Acharya. Indeed, in India, there's a huge scope for a lot of industry-academic collaboration, and especially as the industry enters into the learning phase with all these new megatrends coming, I'm sure the case is much more stronger now than ever before for much more industry academic collaboration. Now, thank you once again for your presentation, and I would like to request Mr. Harshad Karve of ANSYS to kindly come and felicitate Professor Acharya. We are running a little behind schedule, but I hope you will bear with us. And I know lunchtime is approaching, but we have the next speaker, the last speaker before lunch break, is Mr. Harshad Karve's presentation at IIT Guwahati.
So while they set up this presentation, let me offer a few comments based on what I've heard so far. It's very, very exciting time for me to be here. As Sumantra introduced, I graduated from IIT Bombay around 22 years ago, and we had a similar hall, so all those memories are coming back. In those days, many of my peers in the mechanical engineering, we were all studying CAD systems. The CAD was a big thing then. It was quite established, growing very fast. CAE, as compared to that, the engineering simulations, where ANSYS specializes, was very, very nascent. In those days, on the computers that we had then, it was very, very difficult to actually do any meaningful engineering simulations. Now, today, the sense that I'm developing is that the biggest hot thing right now is electrification, especially if you are an electrical engineer or a mechanical engineer or electronics background, even computers, because there is a lot of embedded software typically in these systems. This is a very, very unique opportunity. This is a perfect timing for all of you guys. Next 10 years, there are going to be a lot of opportunities, as you have heard from the speakers through this morning. I think there are two types of opportunities in front of you. The first one is there. Okay. So there are two types of opportunities. If you are very technology driven, as Dr. Seshu was saying, that there is a lot of R&D that is starting to happen in India. He said that the OEMs in India so far have been just assembling vehicles and importing all the different pieces of technology from elsewhere. That is changing. So that's a very big change. The second reason is that even if you look at Teslas, and somebody was saying that China is much ahead, the gap on the electrification side, the gap between the other countries and India is not, it's only a few years, which means the opportunity is still there as compared to conventional cars, IC engines. If you compare the core R&D development efforts, it is multiple decades of gap. But now the opportunity, I believe, is equal for everybody. So if you are technology driven, there is huge opportunity in the next 10 years to sort of redesign the DNA of the car. And it's not only the car. To support what Ayush said, the biggest thing for India, I believe personally, will not be the passenger cars, but it will be more the 2, 3-wheelers and the commercial vehicles. I think that will be the game-changing technology for India. And over there, I think, I don't believe that the West, the developed countries are focusing so much on 2-wheelers and 3-wheelers. So there is a huge amount of opportunity for not only India, but all the emerging countries, which means we can develop the technology here, make the products, and sell them not only in India, but all the emerging economies will find this relevant. Whenever I'm in China, I see lots of these scooters, electric scooters. They are very, very popular over there. And this is for those of you who are very hungry for technology. If you have aspirations to be an entrepreneur, I think there are many challenges that we have heard since morning in the area of creating infrastructure, in the area of battery, which is still being researched, and it's very clear and evident that the biggest bottleneck right now is importing the battery technology, because that just doesn't make the cut in terms of the price of the vehicle. So there is a lot of opportunities for R&D in the battery and setting up that ecosystem, the infrastructure, the power electronics. Dr. Bala was saying the power electronics is still very weak in India, so there are a huge amount of opportunities if you want to be entrepreneurs. So having said that, what I will do is sort of extension of what you have heard so far. We have heard from different people, the OEMs, mainly the manufacturers, then KPIT, who are actually bridging the gap and creating and supplying those skills to these customers of them, who are the OEMs and the suppliers who are creating either the components of the vehicle or they are creating the entire vehicle. I will talk mainly about the technology side of it, how we can enable from the technology standpoint and accelerate the entire design process of an electric vehicle or even electric vehicle components. And that's, as you know, how many of you know ANSYS? Okay, quite a few. So as you know, ANSYS specializes in engineering simulations. We are solving differential equations for various physics, electromagnetic equations, fluid dynamic equations, solid mechanics equations, and we are seeing an amazing sort of confluence of all these different physics coming together. As you have seen, all the structural, thermal, electronic, electromagnetic challenges come together when you want to integrate all these different pieces into an electric vehicle. If you look at the battery independently, if you look at the power controls independently, none of these technologies are really brand new, but how it comes together in a meaningful way, in a cost-effective way, is actually creating huge scope for innovation. And that's where we play a big role at ANSYS. We are enabling this from a technology standpoint. So quickly, I'll summarize what you have heard so far. None of it will surprise you, but it just little bit global view, because ANSYS, the top 500 companies in the world are our customers. So we are seeing this evolution of electrification very, very closely, not only in automotive, but also in aerospace, defense, and healthcare, and many sectors. You can see this trend of electrification. We are working with all the OEMs in the world. I specifically, because I focus on Asia, I have been working closely with the R&D teams in Japan, in Korea, in China. So I have a very good understanding of how these OEMs and the supply chain is actually gearing themselves up for this EV challenge. So all these factors we have heard a lot. Fossil fuel resources are drying up, the gasoline prices, the environment concerns, and especially the last one, that the battery pack cost is now reducing. It's almost already reduced to $200. It's more than that for India because we are still importing. So these are very obvious drivers. Each and every OEM in the world, you can just go on their website and look up their EV strategy. You will find lots of material. Here I've just given 3 examples of General Motors, Toyota and Volkswagen from the 3 continents, the North America, Europe, and Asia. All of them have a very clearly laid out electrification strategy, very clearly laid out goals in terms of timelines and so on. So you will find this in all the OEMs, and it needless to say that all the suppliers who are supplying to these OEMs are also investing very, very heavily in electrification. I do believe, for a variety of reasons that have been stated in the morning, I do believe the timing is perfect for India. There are various factors that are driving this, and what's different and interesting, and I'm referring to the roadmap now, that I do believe that the two-wheeler and three-wheelers will be the biggest emphasis for India, as well as the commercial vehicles, because of the cost-benefit ratios that all the calculations we have seen through the morning. It will be quite some time before it becomes attractive to have fully electric passenger cars for the Indian audience. But I see that, I sense, and it's already, there are a lot of products in IIT Chennai. I know one startup who have already manufactured and launched a two-wheeler earlier this year. So you will see pretty much each and every state in the country has some kind of a startup or a company who is focusing on two-wheelers and three-wheelers. So this is going to grow very, very quickly. The second thing that I see is the charging infrastructure. We have seen, again, a lot of discussion on this. Very unique. I don't believe the solution. I have been to Japan many times. I have seen how they have set up the charging stations. That kind of a solution is not going to work for India. India is very, very different in terms of geography and economy and various things. So we will have to come up with some unique solutions that are suitable for our conditions. So with that, now let me switch gears and get a little bit technical. This is going to be the most technical presentation so far, I think. Given the background of ANSYS, we are solving this physics equation. So this is the ANSYS vision. We have a new CEO as of last year, and we revised our vision, and we have expanded out of the digital prototype. We have been focusing on building digital prototypes by solving all these different physics and bringing it together, so you can evaluate your product in a virtual environment even before you are actually building a physical prototype and doing the testing. Now we have extended that to even the concept design, and therefore we are investing heavily into model-based systems design and various other exploratory discovery. It's called ANSYS Discovery Tool. So we are coming up with new tools on the left-hand side, the concept, which I think is very, very relevant for electrification because of two reasons. There are only two ways you can produce an electric vehicle. One way is that you take an existing design and retrofit, and you say, okay, I'm going to put some batteries, make it a hybrid, and start retrofitting it. The other way is that you do it grounds up, and that's typically done when you have a fully electric. When you have a fully electric vehicle, it's actually cheaper and faster to do a grounds up design rather than retrofit a IC engine based design. So for both of these, you have to evaluate a lot of concepts, and we are coming up with tools which designers can use without having to worry about the physics. The physics is sort of taken care inside these products. On the right hand side is the maintenance, the digital twin. I think you may have heard. This is a very hot trend. It's a lecture on its own, so I'll not spend too much time on that. So these are some of the corporate initiatives we have: additive manufacturing, electrification, digital exploration, and digital twin IoT. The reason I put this up is to tell you guys that across ANSYS Global, there are these 4 corporate initiatives, and one of them is electrification. So this is really, really a big deal. It is a mega trend. What we have done in the last few years, that we have continuously engaged with various OEMs, government labs of highway vehicles like tractors and so on, academia around the world, tier 1 suppliers, component suppliers, the entire ecosystem, and we have been learning from them what are the different initiatives that they have. And what we find is quite similar to what Dr. Bala has shown this morning, that 12-volt conventional and fully electric on the other side, and you have everything in between. Because all these OEMs have this challenge that how do they leverage the existing assembly lines and the supply chain and the platforms that they have and start moving towards the right. And each of the OEMs, interestingly, have very different approaches, how they are doing this, depending on the investments they're putting in, the kinds of goals they have, the market segments they are targeting. But no matter what kind of vehicle you're trying to produce, typically all electric vehicle have these kinds of systems. So there is at the very top level, you need an architecture where you define all the different functions. Then underlying that, there is a software piece, all the embedded software that goes in, and underneath that, there is actually hardware, different systems who are behaving, taking commands from the software, interacting with each other. So ANSYS has solutions for all of these different systems, as well as a system level solution. So because we say our vision is pervasive engineering simulations, we are investing not only in having products in these different physics like the fluid structure, electromagnetics, and so on, but we are also making significant investment in building a platform which brings all of these things together. So particularly for electrification, we have a very comprehensive simulation environment. You can see the battery solution, the embedded software, the mechanics, all the different components can be individually solved on that platform and brought together in an entire system simulation as shown on the right hand side. I'll not get into each of these 6 pillars. You can trust me that we have solutions for all of these main 6 pillars. I'll just give you some success stories or examples of what people have recently achieved with simulation. The first one is the battery. We have heard a lot about the battery. Battery is the key component in any electric vehicle, and there are several engineering issues that one has to tackle, right from electrochemistry, which is pretty much inside the cell itself, to the thermal electrical simulations, thermal abuse, reduced order models, and all this has to be done not only at the cell level but at the package, and then how it integrates into the vehicle. The best example that we have seen so far is Volkswagen. You may have heard about this race. A fully electric vehicle, Volkswagen vehicle, actually beat the record. They went up the Pikes Peak in 7 minutes, and this is huge. I mean, you are all engineers, so you can probably appreciate to beat a previous record by 2 minutes is huge. And the secret was very simple, that all these different competitors were afraid that the batteries are going to heat up, and therefore they are mostly air cooled, so they kept the vents open. However, Volkswagen worked with ANSYS team, and they explored this new scenario that if you close the vents, the cooling vents, can the battery survive for the 9 minutes as it's climbing up? And through simulations, we actually demonstrated to them that it's actually okay to close the cooling vents, and it dramatically changes the aerodynamic performance, obviously, right? Because you close the vents, then the drag completely changes, and they were able to set this new record. And they got this confidence through simulation that yes, the battery is going to work even if I'm not going to cool it for that long. The other one is electric machines. That's another core piece in an electric vehicle, the traction motor. And again, there are various issues. The electromagnetic optimization is the obvious one, but there again, thermal issues, noise, vibration. Noise has become a big one. It may not be obvious to some of you because the most noise today comes from the IC engine. But when you take it out, then all other kinds of noises comes on, and even the motor produces a lot of noise. So people want to make it completely silent. Yeah. So here is an example of EM motive of how they have done simulations in ANSYS for their entire electric motor. So this is an excellent example of how they never actually developed a physical prototype. They did their entire design, all the iterations on the ANSYS software itself, optimized for all these parameters that you see on the right hand side spider chart, and then only made the final prototype. we have heard a lot about charging. The biggest, hottest thing that we see is wireless charging. And Qualcomm, and this actually brings me to another point, that Qualcomm is a chip maker, but you can see that they are investing into wireless charging. So there are all kinds of companies like the Googles of the world are jumping into this electrification and autonomous and all these different trends. So I believe that the opportunity is there not only for the OEM makers or traditional auto players, but really it's open. Any industry, any company can think about venturing into some of these new trends. So I'll end with a video, and this is where actually the entire vision of ANSYS has been realized. So this is a startup company called Lucid Motors, and they have used ANSYS. They have developed this fully electric vehicle grounds up. No historical designs, nothing. They have developed this grounds up entirely based on simulations, right from the concept design, system design, all the way to the end. So this is really, really great to get a testimonial from Peter, the CTO of this company. So let me see if the video plays.
The real breakthrough that Lucid Air represents is that it's really the first time that anyone's taken the full potential of electrification and applied that holistically to a complete vehicle design. And to that aim, we had to use world-class simulation tools in order to create this world-class product. Lucid Air is going to take electrification to a whole new level. People are not expecting this. When we look at the way a car is designed with a traditional methodology, even with a high-tech methodology, which is still traditionally its nature, we look at a 6 to 7 year program. Here at Lucid, we've compressed that program to 3 years, and we've done that largely through a simulation, great people, great engineers, but using great equipment and great tools. I'm a proponent of making that physical prototype late. It's a very counterintuitive approach, but it's proven to accelerate the timescale of product development and, moreover, to create truly excellent world-class products. And the reason we can do that is because we have great confidence in the fidelity, the virtuosity of our computer models. That way we can run virtual prototypes at many, many times over. And we can learn so much more from a computer prototype than a physical prototype. We love using ANSYS, great partner, great tools for the engineer, and the application of those tools, which is together to make great product as a team effort. We're able to make Lucid Air work with a very small team, a very dynamic and dedicated team. A large proportion of that team is engaged in simulation. To really reap the full reward of a deep computer analysis, we need to see those system models integrated, and we do that in a multi-physics environment using ANSYS. And that has been the key to the significant breakthroughs that we've made here at Lucid on the Lucid Air to make this the most advanced car in the world.
Yep. So before I close, I just want you to, I want that you get introduced to some of the ANSYS team here so that we are able to interact even after this. So Roshan is here. He is our specialist in electronics, electrical domain. We have Ankit at the back, who is expert in battery systems. We have Bappa. Who else? Anybody else from ANSYS? So this is the team we have. We are all around until the end of this event. So please approach us, and we'll be happy to have discussions with you. Thank you.
Thank you, Harshad. May I request you to stay back and lifespan. It's interesting to see how the kind of impact simulation technologies can bring, as we heard the gentleman saying that bringing down roughly by what 50%?
6 years to 3 years.
Yeah, so that's a drastic reduction in product development time. So it's an interesting example. So congratulations to ANSYS on that. Now I would like to request my colleague Nilesh Wadhwa to come and please felicitate Mr. Harshad. We hope you like the book. Okay, with Mr. Harshad Karave's presentation, we come to the end of this session. Now we break out for lunch. I know we are a little behind